Welcome, everyone. This is Mike Gibbs, and we are here for the free live CCSK Certificate of Cloud Security Knowledge. This is a program that's designed to teach intro level security, intro level cloud security, and I'm really happy about it. We just to let you know, we stream video through a third party streaming provider. We send it to them, and they send it out, and they're having some congestion right now. So apologies for there'll be a points where my video looks a little choppy like this, and hopefully when we play the videos and certain videos for you, that's not the case. We'll be using a different streaming provider tomorrow if need be, because we always have a backup one. So welcome everyone. So we're going to spend the next week or so, and we're going to talk about security. We'll be here from 2 to 5 p.m. We're going to talk about cloud security. We're also going to talk about cloud computing, what it is, what are the challenges and differences between traditional security and cybersecurity. And this should be a fun time, and I'm all excited about it. I love doing these things, and let's have some fun. So I want to let you know about some free things to help you this week in your security career. The first is that my team wrote a ebook, a set of a study guide that matched some of the training we did in order to help you with the CCSK exam and help you take notes. So please make sure you sign up for the study guide. And this is going to be a comprehensive study guide that my team wrote for you. It's going to be hundreds of pages long. And it's going to help you prepare for the CCSK exam. And it's also going to be some security things that you should think about. And it's free, so please get it. And I want to make sure that it becomes a good experience for y'all. So please grab that. Now, on Thursday at 11 a.m. Eastern Standard Time this week, we're going to have a webinar on how to become a security architect and a cloud security architect. So if it's a goal career of yours, we're going to talk about all the things you need to do to get there. We'll talk about every skill you need. We'll talk about what managers are want. We'll talk about exactly what we do in the role, because most people prepare for the wrong role. And it's all free. And then there'll be about 90 minutes that will answer any career questions you have about anything, because we just want to help you in your career. So please sign up for that if that's a goal of yours. Now, if you're here for other cloud security things like security admin or engineers, that's great. But if you want to be an architect, join us on Thursday. So what we're going to do this week is we're going to speak for approximately 20 minutes at a time, and then we'll answer questions for approximately 20 minutes at a time. So that's typically what we're going to be dealing with and the format of the week. Now, I've been having some back challenges for the last couple of months, which I'm getting addressed next month, thankfully. But the key is I didn't know whether I'd be able to sit in my chair or not sit in my chair, but I promised the CCSK Certificate of Cloud Security Knowledge Bootcamp, and it was free. So what I did is I pre-recorded a lot of the videos here in order to make sure that whether my back was good or not this week, I was able to make sure we delivered on this. Because when we promise something, we deliver on it. So that's going to be the format of the week. So make sure, give me a hashtag CCSK, or give me a hashtag Cloud Security Architect or something like that, so I know you're awake, you're alert, and oriented. And in about a minute or so, we'll actually begin with the program. And while you give me that hashtag so that I know that you're awake, maybe invite a friend, send a tweet, send a LinkedIn profile, go to WhatsApp and text somebody or something like that, or iMessage someone. If you know someone that can benefit from this, or you think others can benefit, share the free knowledge. It costs a lot to put a program like this together. And we just want to make sure that it gets to all the hands of people that couldn't afford training otherwise, because we're going to go deep here, a lot deeper than most courses would go, and we're going to do it free. So I see some hashtag CCSK. I'll wait for about 30 seconds more. I keep seeing these CCSKs. I love watching it pop in. I think it's pretty terrific, and absolutely love to see where people are coming from. So let's have some fun. Strap in. As you get questions on the course, don't be shy. Pop them in the chat box, and then the next time we have a break, we'll answer them, because I want you to know that we really give you a good experience and you bring a lot of learning from this. So thank you. And Chris, let's start the video content. Okay, so we're going to begin with Domain 1 of the Certificate of Cloud Security Knowledge, the CCSK certification exam. And in Domain 1, we're going to have a lot of fun. We're going to talk about some cloud computing concepts and various types of cloud computing architectures. We'll talk about their benefits, the strengths and weaknesses of each, And we'll really make sure you understand what is cloud computing, the benefits of cloud computing, the things that it does and doesn't do, separate the fact from fiction. And that's going to be the basis of this section, because if you want to secure a cloud, you have to be able to know what the cloud is and know what you're actually securing. So what is cloud computing really? Well, cloud computing, realistically speaking, is nothing more than renting space in someone else's data center. Now, there's going to be a lot of names and definitions which we're going to use, and I'll give you them first. And then after that, what I'm going to do is I'm actually going to design a cloud with you. We're going to whiteboard the entire cloud out. We're going to whiteboard a data center out. And I want you to see the differences between the legacy technologies and the cloud technologies, and the differences if you can find any. And with that knowledge, you'll understand how to secure the real world, which in today's day is hybrid multi-cloud in most cases. And we'll talk about that too. So there's the first definition of cloud computing I'll give you is from NIST. So it's from the US government. And it says cloud computing enables an on-demand network access to a shared part of configurable resources, example, network servers and storage, with minimal management or service provider interaction. Okay, what does that mean? Absolutely nothing. But we're going to talk about it in a minute. The International Standards Organization has their definition that says cloud computing enables network access to a scalable, elastic pool of shareable resources with self-service provisioning and on-demand administration. Again, what does that say? Not a whole lot. And that's why the majority of people struggle with cloud computing. So we're going to actually whiteboard out a cloud right now. Well, actually, I'm going to whiteboard out a data center, and then I'm going to turn it into a cloud, and then you'll understand the difference. And then we'll be using these references as we go through various architecture patterns. So I'm going to bring out my whiteboard. So the first thing we're going to do is we're going to design a cloud. So the first thing we're going to do is we are going to get a building. And we're going to call it a building. It's a data center, but so it's going to be a special building. And I'm going to empty this building out right now. And I can tell you what we need to do in any kind of data center or cloud. We need to bring in a lot of power to the building. So we've got power coming in from more than one places. I'll call it a P. We typically, in a perfect world, whenever possible, have multiple power companies coming in. And we typically also have different power transformers coming in. Now, we will also have networking connections outside of this building. And this will be, say, network connections that go to this will be, say, the internet. I'll make this look like internet because there'll be a different set of connections. And then we will have another set of network connections that connect to various parts of the world or other offices that we have, private connections. So I'll call that intranet. Now, in this cloud provider, you're going to have a few things. You're going to have AC, cooling, generators. So let's put a couple of AC units in here because we can't have single AC units. We're going to have huge AC units, but they have to be redundant. In case things fail, you need some cooling to keep the systems up. Now we need generators in here to bring in power, which kick in, for example, if anything were to happen to our environment. And then we typically add battery backup that gives us some time before the generators would kick in if we were to run out of fuel for a few minutes. And these are called uninterruptible power systems. Now, in this environment, what we're going to do is we're going to have routers and switches, which I'm just going to make them look just like this to make it simple. Routers and switches. And it's not going to be the prettiest example, and then what you're going to see is we're going to have racks, and in the racks, we're going to have these little things. We're going to have servers that are in the racks. And the servers, oops, didn't mean to do this, bear with me. We'll have many of these servers, and you'll see what happens is the servers are going to be plugged into these switches. So we're going to make those connections. Let me just make it a couple. Now, there's data centers that have 20,000 of these servers, and there are 30,000, 40,000. So huge data centers that we're talking about. Some could be small, some could be large, but we've got these are wired in because servers never connect to the system via wireless whenever possible. They always use wired. Now, what else will we have in our environment? We will have storage area networks, things like block storage. We will also have network attached storage, which is file storage. So what we're going to have is storage networks. Now, what's going to happen in these storage boxes, actually, let me turn this into black text so I can show you what you'll see in these storage boxes. If I can go back to figure out what my text color is. Okay, here we go. Let's change this color to red. Let's change this to storage to red. Let's get rid of the fill in here so I can actually show you what's going on in the storage environment. So let's expand those. What you'll see is you'll have a storage environment, and what they're going to do is they're going to have a whole lot of little hard drives in them. And these hard drives will be using something called RAID, where basically you put them together in a redundant environment where they can share capacity. So you'll have these little storage environments, and these storage environments are going to have switches that get plugged back into the routers. So now when you have a server, let's say this server over here that needs access to storage, it's going to get it through the network. And there'll be 3 storage types we'll talk about throughout this program: block storage, object storage, file storage, but this is typically the way that it's set up. Now there will be things that we also need going outside of the world. So we will need firewalls to protect us from security perspectives anytime we go between barriers. We will need additional routers that are connecting all over the place. So we're going to have some more routers over here. Now we may also have some containers, like a containerized environment, which basically means we're going to have some servers. And those servers will be running a Kubernetes cluster, which are no different than any of these servers, realistically speaking. But when that environment happens, we're going to need some servers that control things. And there's a reason I'm introducing the concept of a control plane right now. We're going to get there really soon. So let's say I'm going to call it a K8 server. It's just a control plane, the orchestration. Now these servers, these little virtual machines, of course, will also be plugged back into the network, but we're going to remove that wire. And then what will ultimately happen is we are going to be running our containers on various servers using container runtime. And that's realistically what we're going to see. So this is how our containers have been running in our data center for the last decade or more. This is the same way they are in any cloud computing environment. Now you'll also see environments where we have to load share among servers in the data center. So what will we have? We'll have these machines called load balancers, and they'll be physical appliances in a real data center. And we'll have storage, and of course we'll have the applications that we would run in our data center. So we might put our applications on servers, etc. So right now what you see, for the most part, is the basis of a data center. Now, this is the same this is a data center that a business would build. And then this is the same kind of data center that a cloud provider would build. Here's the difference. In a traditional data center, we use virtualization, which I'm going to talk about in a little bit and show you what that's like. And the virtualization layer, let's say it's VMware that we're using. We could be in an environment like this. Let's say it's our data center. Let's say we're running VMware. And we're pulling our capacity. So we've got all these servers. And realistically speaking, we can plug these servers into the network. We can have extra servers that we don't need that we plug into the network. And here we've got a VMware control plane. Oops, sorry, didn't mean to go off of that. And all of a sudden, Mike wants to create a server, or the user wants to create a server. We go to the VMware control plane and say, I need a server with a specific number of cores and a specific amount of DRAM. And then VMware looks through its pools of servers and says, this server has the capacity, and it puts its the virtual machine on this server because it's got unused compute capacity. And that's typically what we do in the data center. Now, for this, in the data center, here's what you have to understand. You have to manage. You have to manage the power coming in. You have to manage these networking connections coming in, the physical security of the building, the physical security appliances, the physical load balancers, the physical storage, the AC, the power, the cooling, the real estate. You got to manage it all. This is a private cloud, by the way. This is what almost every company still has. And this is what they've been using for the last 20 years, except for Kubernetes. But these kind of data centers consolidated like this were from 1999 when VMware invented the hypervisor. Now let's turn this into a cloud. Now, instead of the customer buying this, in this case, this is customer bought. Actually, let's add this before we shift onto the public cloud. So in this case, this is the customer owned. Let's make this look a little better. Now, let's go to the cloud provider instead. Here's what that's going to look like. It's going to look the same. Now, what's going to be different here is this is not going to be VMware managing it. What the cloud provider is going to do is have their own cloud provider control plane. And what does the cloud provider's control plane do? Well, the cloud provider manages the pooling of the resources. So you need a server, you go to the AWS management console or the Azure console, the Google console, use the Google CLI, I don't care. And then what the cloud provider's console says, okay, here's my servers. This server's got capacity, put your virtual machine on here. Now you want to, and it's the same thing. It's the same storage that they had in the data center, although the cloud provider buys a lot more of it. The cloud provider, for the most part, buys the same servers as you do. And they buy the same storage as you do. They buy the same physical load balancers that you do, the same physical firewalls for the most part that any other company would do, the same kind of air conditioners, the same kind of generators, the same kind of everything. But now the cloud provider owns this. The cloud provider owns this. You don't own this. So when we deal with cloud computing, what are we really getting? When we subscribe to something, what we're getting is a virtual data center. And in this virtual data center, what you're going to do is as follows. Let me just, let's get rid of the fill in here. You're now going to create your own virtual environment. So what will you have in your own virtual data center? Well, you'll have virtual routers, because that's going to take your traffic from one subnet to another subnet. You will have virtual load balancers instead of physical load balancers. It's going to be a load balancer, and you might use that same load balancer to load balance in between virtual machines. And these are going to be the same virtual machines you had in your data center. Or you could be using a different load balancer to load balance in between containers, like say, and that would be fine. This could be a container. Same containers that you would actually have in your data center. So you're starting to sense something. Now you connect to storage. No, in this case, you're connecting to a storage area network, whether it's block storage, object storage, or file storage. You're running your applications. You're going to put your database on a virtual machine in a data center. So everything you get, whether it's your VPC or your VNet, because AWS calls it a VPC, Azure calls it a VNet, for example, it's all rental space in someone else's data center. So that's cloud computing. Now, where's the difference? And this is the difference between the data center, and then we're going to talk about the infrastructure as a service, and then we'll talk about platform as a service and other types of things so you truly understand the difference. In the private cloud, we have to manage all of this stuff. We're managing the control plane, we're managing the AC, the generators, what have you. Now, in many cases, if we manage this ourselves and we're good at it, the private cloud is going to be the cheapest. Oh, and there's going to be lots of reasons for it if we're good at it. But if we're not good at this and we're not proficient at this, the AC, the power, the generators, the cooling, the networking, well, it gets really complicated. The storage gets really complicated. So by going to the cloud, assuming you were only leveraging the cloud, you no longer have to manage this building. Now, this is the cloud provider. It looks just like your data center, but it's bigger, and they've got a control plane that they manage for you. The cloud provider is managing the AC, the generators, the routers, the switches, the underlying hardware of the servers, the underlying storage area network. All of that stuff is done for you in cloud computing. And because of that, cloud computing is very simple. There's a lot less from an overhead perspective that you might actually need. Because at the end of the day, you're managing a virtual load balancer and a virtual machine. You're not managing the physical server underneath the virtual machine. I'll give you an example of what we mean by this. So these are what your servers are going to be like. Let's say you've got a server, and the server has 384 cores in it, and it's got 4 terabytes of DRAM. What ultimately happens in any of these environments is in your data center, you have to manage this hypervisor. That's your work in traditional data centers and a private cloud. But in the public cloud, the hypervisor is already done for you. So in a cloud computing environment, all you have to worry about is managing is the virtual machine. All this stuff is taken care of you. That's the difference. In the data center, you have to manage all of this. In the cloud provider, you only have to manage this, your stuff. And in infrastructure as a service, you're managing this, your virtual data center, which is a whole lot in the entire data center. Now, because of this, the cloud provider is going to charge you a premium for the convenience of you not having to deal with it. So things often cost much more in cloud computing than the same thing because you're paying for the convenience. Someone else is managing it. Now, there'll be times when cloud computing is cheaper and there'll be times when cloud computing is more expensive. But if you understand what cloud computing really is, you're renting space in some giant set of data centers, basically like a room inside of a hotel. Hopefully that clears what is cloud computing. Now, because you're in that virtual environment, remember how I created that virtual VPC or virtual data center in the cloud? What you're getting is you're getting pooled resources that the cloud provider already put there for you. You're no longer thinking of managing the physical stuff. The cloud provider is doing that. The orchestration of what stuff goes where, the cloud provider is doing that. You're managing your stuff. But remember, cloud is multi-tenancy. And that has implications in terms of security as well. I want you to think about protecting a dignitary in a private residence versus protecting a dignitary in a hotel with multiple ingress, egress points and thousands of other people inside of that hotel. Multi-tenancy makes things more complicated. Multi-tenancy also gets rid of some of the elements of control that we might need or desire from a security perspective. But cloud service providers are in the business of having a lot of capacity. That's their business. And their main benefit for customers, in many cases, some of the biggest benefits is that capacity is available when you need it. Grab it immediately and use it, as opposed to having to call a provider, waiting for the provider to send you the equipment, for example. So for the purposes of the exam, I'm going to give you the cloud computing benefits. And then after that, I'm going to talk about the reality of the cloud computing benefits. The benefits that you typically hear about are agility, which is very true. The ability to change directions or move dynamically. The cloud is very good for that. Resiliency, meaning lots of systems, lots of things can fail and you still being up and operational. Great. Definitely, you get that from cloud computing if you design your architecture where you use enough cloud providers and things. Security, cloud computing can be secure if it's designed properly, almost as secure as the data center. And the reason I say almost as secure is in the data center, you have one set of risks that you get hacked. In the cloud provider, you have the same set of risks that you get hacked, but you also have the risk that the cloud provider gets hacked and you get attacked through them. So it's a slightly bigger risk on the cloud. Having said that, organizations with well-run data centers could be more secure because they can add a greater level of security and network security and customization unavailable in cloud computing. For organizations that don't have well-designed data centers and they don't have the expertise to run them, cloud computing is often more secure. Now, cloud adoption, we're having a lot of challenges because it's been very expensive. And people thought they were going to the cloud to get cheaper costs. And most of what people did is they took the things out of the data center exactly as is, take your virtual machine to the data center, move it to the cloud, and the only difference is they went to a virtual hosted convenience data center from the original data center, and people found their cloud costs rise extremely high. David Lithicum, the cloud computing expert, said that 250 to 350% on average, 250 to 300% is what they're seeing in cloud computing, costing more than the data center. It's about what I've seen as well in my work. So cloud computing can be expensive if it's designed wrong. And the lift and shift, just take it and move it, really didn't provide any benefits. Theoretically, if the applications are optimized to run on the cloud, they may offer, in some cases, better pricing. Having said that, everything that we're going to talk about in terms of compute that you can do on the cloud can also be done at the data center without having to pay the additional fees of the cloud provider raising your data center. Because remember, it's a hoteling business. It's a landlord-tenant business, meaning if it costs me $1,000 a month to build it and run it, I have to charge you more than that. So keep that in mind. So let's talk about some other cloud computing models that you may hear about. You may hear about NIST and ISO computing models, and there's some reference models they have here. But the characteristics of cloud computing, according to NIST, which is the US government, is resource pooling. And it's that dynamic allocation of your stuff out of that pool of resources, which we talked about before. It's that broad network access, meaning the network's already there. The cloud providers have networks between the regions. The cloud providers have networks to the internet. They've got networks to many other people. So you've got a big network that's already there and you don't have to build it. The concept of elasticity or speed or agility, meaning in cloud computing, you want additional capacity. For the most part, you just add it. It's no big deal. In your data center, for that to happen, you'd have to have extra capacity. Meaning you'd have to buy it ahead of time. The cloud providers buy it ahead of time because they don't know which customers are going to use it and when. Measured service. In the data center, you don't pay to use your stuff, but on the cloud, you pay for almost everything. And these nickel and dimes can add up so much. And the last key component, according to NIST, of cloud computing is that on demand, meaning you pretty much set it up anytime you want. You don't have to talk to too many people. The ISO adds multi-tenancy to that same similar kind of definition. So now we're going to talk about various cloud service models. And NIST defines 3 broad cloud service models: infrastructure as a service, platform as a service, and software as a service. And typically speaking, these are the businesses your cloud providers are in. And we're going to talk about them. Infrastructure as a service. Okay, I'm going to make it very clear. Infrastructure as a service is your rental data center. So going back to my design pro where we created a virtual data center, we put our virtual machines and our load balancers, and we're running our containers on side of virtual machines in here. This is a virtual data center. This is infrastructure as a service. With this, I have the most control. I have the most control of my networking. I have the most control of my compute, my most control of everything. You can manage this via web interfaces. We can deploy this kind of stuff via infrastructure as code for the cloud engineers that do that. Now, that is a virtual data center, infrastructure as a service. By comparison, platform as a service is something a little different. And I'm going to draw that out in the data center, and then I'm going to show you pretty much what it is in the cloud, because we have it both in the same data center and the cloud. So let me go back to my little whiteboard here. So now let's take a pool of servers. We're going to create a platform as a service environment, exactly how the cloud providers enable it. And these servers are a pooled source of resources. And then these servers run something called an application virtualization layer. And what they do is they enable you to put application 1, it's code, and then you can put application 2's code on the same server, and then you put applications 3's code, and then they're just separated from each other. So with the platform as a service concept, you upload your code and it runs. But what you lose here is a lot of control. You're no longer worried, and actually, let's go back to this. So you no longer really have any control over the operating system that's running inside of the servers for the operating system that these application virtualization is running on. So you've got, anyway, some kind of this application virtualization OS kind of thing. And these virtual machines are separated from each other. And what you're not saying, and the reason I wanted you to put the operating system is the cloud provider is managing the operating system where these things are housed. They do this. So all you're doing is uploading your code and going. And there are a lot of ways that these things are pretty much there, or these are a lot of managed services where you just upload your stuff and it works. But for the most part, this is pretty much application virtualization, where in this particular case, the cloud provider is managing underlying servers. And there's lots of examples where pretty much cloud provider manage the underlying infrastructure in platform as a service. Upload your code and go is an example of this. Now you're not managing the operating system, for example, and all those other things. So that's one thing for you to think about. And then there's the concept of software as a service. And software as a service is when something is completely managed by somebody else. It could be the cloud provider like an AWS, Azure, or a Google, but it could also be just an application you pay for. So if you think of Microsoft 365, where they're managed, where pretty much you log in and all of a sudden you have access to your OneDrive, which is like cloud storage. You've got access to your Word documents. Multiple people can edit something together. That is software as a service. Zoom is software as a service. It's hosted, it's run somewhere else. You just get your account. And this is another example of software as a service type model. Now you may be able to connect to things via a web browser, mobile app, or an API, but you're not managing so much of it. Even the storage in many cases is managed by somebody else. Welcome back, everyone. Looks like our servers are a little overloaded or something else is going on. So I got rid of my green background to try and make it a little smoother, and we'll see what we need to do today. So let's get through some questions that people asked. I want to make sure you understand it, and definitely want to help. And we'll spend about 10 minutes answering questions right now. If you're enjoying the content, please give it a like. If you're not a subscriber, please subscribe and hit the bell if you're liking the content. And that way you'll be notified of many things to help you in your technology career, whether it's a cloud architect career, security architect career, enterprise architect career, AI architect career. So just wanted to let everybody know that. So Chris, if you want to bring in some questions. Hello, what tool do you use to design this architecture? So the architecture is always designed by your mind. And when you design the architecture, you're looking at what are the business challenges? What are the key business processes, for example? What kind of risk does an organization have? How you would manage that risk? So it's going to take a process of you creating and leading a team. Now, if you're asking what I actually designed or drew the architecture with, realistically speaking, it doesn't matter. I was using PowerPoint. And the reason I use PowerPoint is, the kind of architectures I design that are typically $1 billion architectures plus. Nobody wants the designs that I would have drawn in Visio. I give them something like I've drawn right here, and then they give it to a graphic artist in Adobe InDesign, and then they put it in the proposals, and it looks much prettier. But common tools that people use are Microsoft Visio. Works great, super easy to use, but you have to use a Windows system or a Windows virtual machine to use it. It could be Lucidchart or Draw.io, which you can also use via a browser. There's other tools that businesses use, like Archetype and others, that in mapping out certain things, but in enterprise architecture. But all in all, it doesn't matter what you're drawing your pictures with. The architecture is not going to be a picture. It's going to be a picture with a large number of documents in there. Documents for the top level architecture, documents for various viewpoints, like say a demilitarized zone versus some other part of the systems. So, these are the kind of key things you need to think about. It's going to take a lot to design the architecture. The easiest part is learning the drawing tool, which use any tool you want, PowerPoint, Lucidchart, Draw.io, that type of thing. Deep Stereo, I don't understand anything. So let's talk about that. So if you don't know what a server is and you don't know what a load balancer is, then ultimately you're going to have to watch it again and look up some of these concepts. Most people are usually able to go through this and understand a lot because we're giving a lot more details than most organizations ever would with regards to fundamentals. But, there are those people that need to do, say, a CompTIA A plus to learn what a server is, for example. Or not, and you don't necessarily need to do that, but maybe you need to read a fundamentals book for that because we are starting at the beginning, but we're assuming you have certain fundamentals like knowing what a server is. And it's okay. We all start brand new. When I used to practice internal medicine in my youth, when I was a nurse practitioner, the thing is, when I started networking, it was all foreign to me. And I was going to say it's as foreign as Greek, but I speak Greek, but it was as foreign as if it was, say, me trying to speak Italian. But over time, I worked at it, and then it made sense to me. So it's okay. Pay attention, maybe go through it 3 or 4 times, maybe stop and look certain things up along the way, and you'll be amazed at how much you can learn. But we all start somewhere, and we all start at different places. So you'll be good. Just keep at it. No matter what you want to do, you can do. Can I explain platform as a service again? Absolutely. So platform as a service is when you just upload your code and it runs on the cloud provider service. Or it could be a completely managed anything for you where it's just there and running, and all you typically do is add your code or whatever it be. So where might you do this? So let's say I have an application that I need to use in my enterprise environment. And I have a couple of options. One is I could have that application and it could run on a virtual machine. And by doing so, lots of servers have been running this way for the last actually since 1999. The alternative is I can put my applications in a container, in which case we create the container, we pack up the container, and that container can be run on every single cloud. Great way to do it. Standard container Kubernetes orchestration, and you can move your container back and forth between the data center and the cloud provider. Simple, easy. And with 98% of organizations using multi-cloud, the virtual machine and the container are often very good options. Now, upload your code and it runs. Now, that's a little different. What's going on is the providers are each managing the underlying code. They're managing the underlying network. They're managing the underlying servers. They're managing their underlying hypervisors. They're managing the underlying virtual machines that's supporting all your containers, for example. They're managing the operating system on that, and they're managing the patch level. And all you're doing is uploading your code. But what if the cloud provider didn't do a good job maintaining the security of all their underlying infrastructure? Well, you have no control over that. You have to hope and assume they do their job. So when it depends on organizations that need high security, they have to be able to check and verify certain things. And platform as a service may or may not be a good idea based upon what their actual needs are. So sometimes it's great. I hope that answered your question. If you need more, please let me know and I'll go deeper into it. Chris, let's bring in the next one. What are the two differences between public and private cloud? So a private cloud, the company builds for themselves. A public cloud is somebody builds the cloud and they rent you space in that cloud, just like a hotel where you rent a room. So if you think of a private data center, private cloud as kind of like a building that you own, because that's exactly what it is. It's a building you own with servers and routers and switches and everything necessary to make the compute work. That's the data center. Now, when you go to the cloud provider, they have all the same stuff. But instead of building a building for you, they build a building that's like a big, giant hotel. And each room in the hotel is basically serving a single customer. So that is the public cloud. Great question. And you rent space in the public cloud the same way you rent a hotel room for the night, for the week, for the month, for the year, what have you, based upon how long you're sitting there. Is this credential for entry-level knowledge? This credential is entry-level, very entry-level knowledge. It's a starting point. The CCSP, which is also on this channel, completely for free, and the CISM are not necessarily entry-level knowledge. Now, the way we taught them as if people started from the beginning, so they're relatively entry level, and then we go pretty advanced and much deeper than most people do. But the CCSK is very entry level, and that's why we're even mapping out what is a cloud, for example. So yes, this is entry level knowledge, and it's going to give you good fundamentals. Mike, please discuss the high availability options that major cloud providers provide for virtual networks we can design and support with the low latency. So, here's the key. I mean, and this is not, I don't really have, 50 hours or 100 hours to explain the complexity here, which is what it takes, which is why we have a 1,000-hour architect program. But I will easily show you some of the weaknesses you have in a cloud provider. So, do this. Let's go here and let's go back here. So you remember what a cloud provider is they have they have a bunch of data centers called availability zones or zones. So they have data centers, AZ, and what they do is they have geographic regions. And what are geographic regions? They're just a collection of data centers. So you can put two things in this data center and pop them here. So when you're dealing with data centers like this, you're dealing with redundant power systems coming in, redundant cooling systems coming in, redundant networking systems coming in, redundant server infrastructure, redundant storage infrastructure, constant backups, change control procedures, high levels of physical security. But the key is if you actually think of one cloud, let's say you use two, and when the cloud providers can't provide the level of availability in a single customer that you could that a single data center could. A single tier 1 data center will get you to, or tier 4 data center will get you to 99.995% availability, which is about 20 minutes of downtime. The cloud providers, because they can't run heavy duty QoS and other things on their infrastructure because they don't know who's using the system, can't lock their systems down quite as tightly, and they can provide 99.9% availability. So if we use two of these data centers, then we can increase that in a single cloud provider to 99.9. Now, according to the cloud providers, and you could theoretically do this, if you had two sets of availability zones or data centers in a cloud provider, theoretically, that should get you to 99.999%, which is 5 minutes and 52 seconds per downtime, but it won't. And here's the reason it most likely won't. People are trying to attack these cloud providers all day, every day. And even if these regions are separated by BGP, they still have wide area networks connecting every single last one of them. So they've got a WAN between connecting the regions together. And they also have a control plane at the top. So if any kind of major bugs happen to the control plane of the cloud provider, the entire cloud can go down. If anybody hacks into the control plane, they can take the entire cloud down. If the cloud gets hacked in a nasty DDoS attack, it can take the entire cloud down. So, and if if the organization has some major networking problem and some bad routing propagated from one of their data centers to another data centers, it could also black hole the traffic. And again, it can take the entire cloud down. So there's a reason 98% of people wouldn't consider a single cloud provider high availability. And what they would do instead is this. So if you needed some high availability system, you'd put, say, 50% of your systems in AWS. It doesn't matter who they are. And you put 50% of your systems in Azure. And in this particular situation, you send half of your traffic to each place. And by doing so, you don't care which cloud provider goes down and when they go down, because the worst case situation is your traffic shifts from 50% here to 50% here to 50% here. If this doesn't longer exists, you just take this away and you send 100% of your traffic here, and you already have 50% capacity. And then what would happen is auto scaling would take all this to 100% capacity in 10 minutes, 20 minutes, 30 minutes, and you're up and operational at all times. So that's, what we need to do. no matter how much redundancy and availability you put into your systems, if Billy Bob, for example, comes in and does something silly on a router, it can take down the entire cloud. So, or anybody that's untrained, the same way somebody took down a 200 who deleted a $240 billion hedge fund on the Google cloud, or the Google cloud was taken down for an entire day because somebody just made a BGP error. So, I kind of hope that helps and makes sense. You know, that's why high availability almost always uses multiple clouds. Is it easier to create architecture capabilities from drawn down business requirements, therefore streamlining content for your business audience and technical folks? So we're going to have to first go to the business audience and first find the business needs, and then talk about where the vision is the business, and then map out our business processes and business architecture. When we know all of that, only then are we in a position to think about how does that company want to operate in the future? What does that business architecture need to be? And then how do we create that architecture from that content? But we won't know what any of that is until we speak to the audience, speak to the key stakeholders, and many things like that. So it's not. We're going to have to get the capabilities. We're going to have to find the needs. We're going to have to map that all down. And then obviously, when we map down the architecture, and when we create an architecture, we'll have multiple what's called viewpoints. We'll have a viewpoint for the CIO. We'll have various viewpoints for the business executives as it pertains to various business processes, for example. We'll have viewpoints on how data flows through the system, how the networking goes through the system, what the security architecture looks like, what the security policy would look like, what a demilitarized zone policy would look like, what the IAM architecture looks like, what the data architecture. So we're going to have a lot of views, and we're going to have to create a lot of these things. Are there free cloud services in the cloud, for example, to test or learn in cloud? Well, you can configure things all day long on the cloud, but you still won't know what cloud computing is, because if you don't understand the underlying technology, you just know how to configure stuff. And the reality is, when it comes to hiring somebody, if they can't, I don't care if they can configure something if they don't know what it is and how the tech works and where it's needed and what problems it solves and what are the impacts of adding that technology. That's the person I hire. So please learn the technology, and then sure, go build this stuff. Sure, if your goal is to be an engineer, go out there and use AWS, Azure, Google. They have free sandboxes you can use. And then you can also do other things like get an EVE&G server and then do various types of lab testing, networking thing. But make sure you learn the underlying infrastructure first. And if it's a job like architecture, we don't really configure anything. We're all about design. Is there an overlap between the CCSK and CCSP? How soon would you schedule and take the CCSK after passing the CCSK? Well, I might do the CCSP training and then go straight into the I might do the CCSK training and then go straight into the CCSP training and use this to help support that one and go for the big certification right away. I'd consider doing that. Or you could do the CCSK and then immediately after that, go do the CCSP. Either way. What layer is most vulnerable to the cloud architect? I don't know what you mean by that. There's going to be I don't know what you mean by which layer. Are you referring to the OSI model or anything? So, what we're going to do is ask that question again, and the next time we take a break, I will come back and answer that. What is the control plane? So let's answer this as the last question, and then we'll go back to the content. So, in anything that occurs in compute, we have what's called the control plane that manages everything, and then the data plane, which actually does the actual work. So, for example, if we had a cloud provider, and this is the control plane, let me draw this out for you. So, let's say in this environment, we have 10,000 servers. And these are all servers. When you want to create a virtual machine, let's say we need to create a virtual server. So let's say we want to create a server. What we're going to do is we're going to have to the control plane has to look at its available capacity and says, how many servers do I have? Which server has space on it? And then what'll happen is the control plane, you'll tell it, I need a server with 8 cores and 32 gigs of DRAM. The control plane will look for the server that's got capacity, and it's going to say, oh, this server here, this exact server here, this one is where we're going to put the virtual machine. Then the control plane actually pops that onto the virtual machine, and then poof, that's where the virtual machine is. Now, at some point you say delete the virtual machine, you go to the control plane and it removes the virtual machine here. So the control plane is always responsible. Now, we could have this, if this is servers with containers, we might have this. We might have Kubernetes as the control plane, and then each one of these servers, for example, well, the servers will have the server, their OS. And then we'd have a container runtime module, for example, Docker. And Kubernetes, which I spelled apparently wrong. And Kubernetes is live. What Kubernetes would say, oh, well, we need a certain number of containers. Let's add an extra container for this service and an extra container for this service. So the control plane manages everything. In networking, you can manage where the traffic goes while the routers forward the traffic in a data plane. So control plane does orchestration. Chris, I want to get to more questions, but let's get back to the content. I stopped a little too long, and then I will answer other questions at the next break. So I know you're here. If you're having a good time, please give it a like, subscribe to the channel, hit the bell to be notified of new things. And okay, there's one more question we're going to ask. Are we going to have labs to see how this works? As I ask, if you've never seen it. No, this is an architecture exam. And architects never really touch the technology, so we're not going to actually show demos. But if you want to see how packet forwarding is moving, for example, and I wouldn't, and how the networking or some of the underlying infrastructure works, we do have a set of networking labs that you can see that will show how traffic's moving, for example, and how the routers forward their packets. And they will give you very good understanding of the networking, which is at least half of the solutions. So, Chris, if you can provide the information on the free networking labs, that would actually be great. And of course, I've got some free CCNA program on this channel where you can see some of the things that are going on the routers and the switches. And of course, if you look in any of the descriptions of our AWS, our Azure, and Azure training, for example, there are also going to be labs that you can sign up for completely free for these. So you'll be able to see all this stuff in action. But here, this is an exam that's actually based upon questions, and we're preparing you for the actual exam. Those are other things, and I encourage you to do that. I think that's actually great. And these are all going to be free things that we can give you. So I want to remind everybody that our team wrote a completely free set of CCSK study notes. It'll be hundreds of pages in the CCSK cheat sheet to prepare you for that Certificate of Cloud Security Knowledge exam. And we really want you to actually do that. So we hope that'll be good for you. So please sign for that on Thursday this week. We normally do them from 1 to 3, but this week it's 11 a.m. We're going to have a webinar on how to become a security architect. If you want to learn how to be a security architect and all the skills you need, the business skills, the non-business skills, and everything, we'll have that webinar on Thursday. Sign up. It is completely free. And if you sign up for the study guide, it could take 10 or 15 minutes for you to receive it. Our servers get hit with a lot of emails, so we can't send them all exactly at the same time because it looks funny to mail services and security servers. So we have to send them over a period of time when we run a boot camp like this, and we'll get an incredible number of signups inside of a few minutes. But they'll be coming to you. Okay, give me a hashtag CCSK, and Chris, let's get back to the content. Let's talk about some cloud deployment models in NIST, ISO, etc. So there's a lot of ways we can actually architect or deploy our environments. The first option is to go to the public cloud, a single cloud. Basically, we take our things from our data center and we put it in just Azure, for example. That is a public cloud environment. Now, the reality is you're not going to see a lot of these anymore. And the reason is a single cloud is a single point of failure. Because if they were to have a hacking event, a major networking event, or control plane event, you lose the entire cloud, no matter how many regions and availability zones you use. So most people, most organizations, as in 98% of enterprises, use more than one cloud. And even 89% of all businesses use more than one cloud. So a public cloud is just putting your stuff in a single public cloud. The majority don't do this. The next concept is the private cloud. Well, we talked heavily about the private cloud. A company builds their own data center. They run their own cloud software, VMware, Nutanix, OpenStack, what have you, and they've got a beautiful private cloud that they manage. Now, the next kind of cloud is what you call a community cloud. And a community cloud is when a bunch of organizations with a similar interest create their own cloud and share it. So imagine you were in the Boston area and you had 10 hospitals that were all friends, and they decided to build their own cloud and share it amongst the 10 hospitals, or Philadelphia, or any metro. It could be a hospital. It could be any kind of specific industry. So a community cloud is basically when you pool aggregation resources. And by doing so, you've got people that have a similar set of needs, potentially similar applications that they may use, similar requirements, and you're able to build something that's somewhat customized. So a smaller version of a big cloud that's typically in a community of people of specific interest. Now, the next thing that we see is hybrid cloud. Okay, now hybrid cloud is very common. So public cloud is putting all your eggs in the single provider's basket. Hybrid cloud is user data center and user cloud. And let's talk about why an organization might want to do this and why so many organizations do this. So let's say here's the data center and then here's the cloud. We can do two things. So let's say we had a web application. If we wanted to in this particular environment, DNS, if we wanted to, could send 50% to the data center, 50% to the cloud. If the data center went away, for an example, all the traffic would be sent to the cloud. The cloud has auto scaling. If you're familiar with what it is, it would add capacity and the system would be up and operational. Another reason organizations do this is they run their primary workloads in the cloud. And when they need in the private cloud, their data center, when they need additional capacity, they go to the cloud. Why might an organization do this? Well, it depends on the workload where it's going to be cheapest. I might be able to buy a server from Dell for about $300,000 and pop it in my data center. And that server may cost me $4 to $5 million over a few years to rent it here versus the $300,000 to put it here and maybe $10,000 of electric over the next few years. So clearly a high volume workload is much cheaper in the data center. By comparison, a sporadic workload, something that doesn't run all the time, something that's event driven, if this, then that happens, often runs better in the public cloud, cheaper in many cases. So by being able to put the right workload in the right environment, then we can obviously get the best performance. And of course, you'd have networking connections. So this is a hybrid cloud. This is going to be an incredibly common architecture. Now, the next common deployment you'll see is you could see two clouds. You could have an AWS cloud and you could have an Azure cloud. Again, very common. And for disaster recovery, you'd send that to Google, but you might have, assuming it was web-based, and not everything is, you could send 50% of your traffic to AWS, 50% of your traffic to Azure, and let's pick a cloud provider at random that's going to crash. Azure crashed this time, and then all your traffic is sent over to AWS. AWS has auto scaling and can add the capacity. And truth be told, generally speaking, it doesn't cost much more to put 50% of your things in one place and 50% of your things in another. Kind of like for your groceries at Aldi and the other one, 50% at Safeway or Publix. You're buying only one set of it. So that's the multi-cloud architecture. And then I'll tell you what almost everybody has with the big giant enterprise level. And that's going to be your hybrid multi-cloud. And what's that going to look like? It's going to look just like this. It's going to look like an organization that's going to have their private cloud. And that's going to be running VMware, OpenStack, Nutanix, what have you. And then they'll connect to this thing on AWS that AWS does well. Then they'll have this workload running on Azure. Then there'll be something else that Google does better than anybody else. And just, because usually somebody does something a little better than somebody else. And now what we do is we have networking connections to all three. And that's what you call a hybrid multi-cloud. And this is extremely common because cheapest workloads, the highest performance, lowest latency, most control, private cloud. And then you leverage these cloud providers for the availability, their scalability, their agility. And each one of these cloud providers has some tools that may be really good for a business. So these are your typical models that we deal with. So we're going to briefly introduce the concept of an architecture framework. And in this case, we're going to be talking about the Cloud Security Alliance's Enterprise Framework. And it's basically a methodology and a set of tools to create an architecture. And it's really just a framework or an approach for you to look at how you would create a secure infrastructure and the things that could be done and the opportunities for improvement, how you would create a roadmap for the future. How do you identify areas and patterns that will work for you, and ways to assess various cloud providers and things? So a framework is just a structured approach to doing things. There are a lot of frameworks. Enterprise architecture often uses TOGAF. There's a zero trust framework we use constantly in security, which I teach our cloud security architects about in our architecture training programs. There's NIST frameworks, which again would be the kind of thing I would teach in our architecture training programs. But the point is, you need to understand that there are various architecture frameworks that we'll use that will keep us systematic. Now, for the purposes of the exam, we're going to talk about some business operations support services and some information technology operation services and some technology solution services and some security and risk management, because these are based on these enterprise architecture type frameworks. So one of the things we need to think about from the enterprise architecture domain is the business operation and support service area. And the way they do this with the Cloud Security Alliance's frameworks, it tries to leverage best practice from other frameworks. And the goal of this is to take reactive security measures and turn them into something that's proactive. It'll give security architects some thoughts and ways to be able to look at something, to give them some way to put things together. So if I would put together an example to show you what you're looking at this BOSS framework, and you can see this directly, and I would read more about it on the Cloud Security Alliance's website. You can see what you're really talking about. At the business level, you're looking at compliance and governance. Compliance, making sure you're dealing with legal and regulatory issues. Governments, who knows what, how is the things being handled, for example, who's destroying the data when it's time to delete the data. You're going to be looking at operational risk management, whether that be crisis management, business continuity planning, because these are all the things we have to plan for as security architects. We'll be looking at security as well for the HR side. How do we bring people on? How do we terminate them? How do we prevent disgruntled employees from doing damage, that kind of thing. We'll be looking at ways to monitor for security, and it can be anything from a technical thing like a SIEM system, threat intelligence to figure out what's coming at it, looking at monitoring systems, but we're going to be constantly looking to see what's going on with us. And of course, there'll be the legal side of this. So this typically I think about with business operations support services. And that diagram I showed you was directly from the Cloud Security Alliance's webpage, and that's why I gave you the link to it, because I'd love you to go see it yourself. Now, at the same time, we typically want you to think about the information technology and operations services, which is going to be more the tech stack that we're dealing with. And the key here is we really want to align industry standards and best practices with the best things that we're doing here. We're trying to employ analytic services. We're trying to find out what's going on because we really want more details. So let me kind of give you what that's going to look like from a perspective so you can see it. And here again, you're getting into this information technology. Now you're looking at IT operations, right? And the types of things that are going on. And now with IT operations, we've got, we have to make sure we have the right knowledge, that we can evaluate the impact of a change prior to making a change with, say, change management. We need to make sure that our configurations follow a standard set of procedures so we don't have weaknesses in our systems. We're going to have to be dealing with incidents and security incidents when they occur, problems. So you can see the IT side of things is focused more on the IT and the operations of it. But if we can't environment where we've separated the IT operations from the business, and when we do, we get a misalignment between the IT operations and the business, and that's really where things come from. So these frameworks are going to give us some guidance. They'll define policies and audits. They might talk about safeguards that you may be able to use for ways to protect and organize your system. And that's really what we're talking about. Again, we could also be talking about some governance and compliance as part of our architecture frameworks. Things like information security management we have to worry about, which is more measures to eliminate or reduce the impact of security-related threats. We're going to have to look at privilege management, for example, to make sure that the right people have the right set of privileges to perform their jobs, applying to that principle of least privilege where we don't give people access to more than they need to do their job. We'll be looking into threat and vulnerability management. We're going to be constantly having to look and see the kind of threats and vulnerabilities that exist and make sure that our engineering team can test fixes and patches, what have you. We're also going to potentially be employing ethical hackers to try to break in to give us information about weaknesses on the system. And then we need to think about how do we protect that infrastructure. Things like defense in depth, where you put your firewalls, your ACLs, your endpoint protection, for example, lots of things that we can deal with. Then we'll be dealing with data protection, from data classification, data standards, who owns that, data deletion, those types of things, and policies and standards. And obviously, we'll talk much more about these things throughout this program. And policies and standards will define security measures and levels that will be required. And the point is to make them based on risk-driven or business-driven decisions, have a logic behind it. Now, one thing that you really have to think about when you deal with the cloud providers is something called the shared responsibility model. Now, in my data center, I own it. If I'm the CEO of the business, I'm responsible for it all, okay? Because I own it. Now, if I own the network and I own the infrastructure, wow, we can get tight on security. I could say this traffic can go before this traffic, which might be important because we only have a 10 gig link and we had a worm. The worm could fill up the 10 gigs, but we can prioritize traffic and deprioritize worm type traffic on our own network. We can't do that with the cloud provider because they manage the network, not us. So we have to remember we've got this concept of who owns what. In the data center, we own it all. In the cloud, people get very confused. Very confused. So I'm going to try to make it very clear for you. Here's how it works. The cloud provider manages their stuff and you manage your stuff. Okay, so what does that mean? It means that in an infrastructure as a service environment, the cloud provider handles the underlying infrastructure, the servers, the hypervisors, the underlying routers and switches, and you maintain the stuff in your VPC. For the most part. You maintain your storage encryption. You maintain your firewalls, your ACLs. You maintain patches on the operating systems on your virtual machines. You maintain your own IAM users. You maintain the privileges for your users. Infrastructure as a service. It's your virtual data center. You're just no longer managing the physical infrastructure. The cloud provider is. And if the cloud provider doesn't do their job securely managing that physical infrastructure, you're going to be hacked. So we hope and strongly believe, and the cloud providers are good at what they do, that they're intelligently and securely managing their infrastructure. But always have a backup plan. So the next type of my environment is platform as a service. Now here, a lot of the cloud providers could be stuff. What if it's a hosted database for you that's serverless? Well, the cloud provider is going to maintain the server. The cloud provider is going to maintain the storage for that serverless thing. And that cloud provider is going to maintain the database. What are you maintaining is your users, your access to the systems, that kind of thing. If you upload your code and go, it's going to be your code. So you're going to have to make sure your code's good. But, and you might be able to, and there's certain things, but you're not going to be able to do that much. Maybe you'll have access to IAM, for example, and you'll have access to certain integration points, but you're going to have a lot less in a platform as a service because most of it's done for you. But that's the convenience in the platform as a service, is most of it's really done for you. And that's the key. That's what makes it easy. So in an on-prem environment, we manage everything: the servers, the storage, the virtualization, the OS, the middleware, the applications, the network, the data, IAM, everything. In infrastructure as a service, they're managing the storage, the servers, the virtualization. Now you're managing the OS, the middleware, your user space, your applications, your networking configuration. But now we get into that platform as a service, and the cloud provider is managing the servers, so storage, the virtualization, the OS, the middleware. Even to a degree, a lot of the application virtualization, part of the networking, and part of the data. So that you've got some data, some networking, some application, and a little control over your IAM and your configuration. And a software as a service model, basically they manage it all for you: the servers, the storage, the virtualization, the OS, the middleware, the runtime modules, your applications, even the networking. And you've got some access management over your data and some over your IAM and your configuration, and that's it. So these are the types of environments. So understand the cloud provider owns their stuff and you use your stuff and that's how you can realistically think about it. It's shared. So you have to know them, you have to trust them. Cloud service providers should document and make it clear what their security controls and features are. And they need to make it very clear for you. And you basically have to understand ahead of time what your things actually are. There's some tools for cloud security. There's a consensus assessments and initiative questionnaires they talk about in the purpose of this exam, and cloud control matrix, which is a list of various security controls that can be mapped to standards that you can think about. And you can find more about that on the Cloud Security Alliance's website. If you dig deep enough, you will find these things. Welcome back, everyone. So we spoke for about 20 minutes, and as promised, we'll answer questions for approximately 10. We may be a little loose on the 20, could be 25, could be 18, but 17, but our goal is approximately every 20 minutes to answer questions. So, Chris, could you bring up some of the questions that may have transpired? Hello, Mike. Do we have provide apprenticeships for people that are 21 and over, provided they have no experience? Absolutely. We have an architecture program designed for whatever your architecture career goals are. Cloud architects, AI architects, security architects, for example, enterprise architects, whatever it is. And what we do is we create an internship for you. We put you doing all the things that are in the role of the actual job. And we've gotten so many people hired, regardless of the background, whether it was Delray, who went from emergency medical technician to security architect after this program, or Daniel Bosu, who was 20 years old, actually. We worked with him from the time he was 19 and the time he was 20 years old. He was hired by JP Morgan Chase. Or it could be someone like Jennifer E., who was a mental health tech who's now working at JP Morgan Chase. Or it could be with Balwender, who was a stay-at-home mom who's now working as a solutions architect or cloud solutions architect, they call it, over at Microsoft. Or Yvonne, who was a college student and he was working as a waiter, and then he left and went to AWS. So we always work with young people. Check out our whichever architect program you want. You can see them on our website. And yes, these are heavy-duty internships. You will get a title with this. And if you do your job well in class and you start giving the right presentations, we'll even give you a reference. And I do them all the time. So hope that helps. Hi, Mike. Do I recommend to the business to use ITIL with TOGAF? Not really. I use TOGAF with TOGAF. When it comes to business architecture, I recommend more of the strategy consulting type framework. So what would McKinsey use, Accenture, Deloitte, KPMG, and how do you start there? How do you go ask questions? How do you generate a mutually exclusive, collectively exhaustive hypotheses? How do you test your hypotheses for right? How do you map out the business architectures? I use more of a normal consulting framework. And most enterprise architects that are out there really are going to be doing this. A lot of the enterprise architects are going to be people that were MBA executive, like strategy consultants, because they're called business architects, and that's still enterprise architecture. Some of them were people that once worked in technology or didn't work in technology. For example, Jermaine was a student of ours, and he got his first job as an enterprise architect. Or Wallace Agana, for example, who was a sales rep who got his first job as an enterprise architect. But all in all, we either come from a business or tech background or the right training. And what we're dealing is a hybrid business and technology. So when I use business, I use the more business oriented things. And when I use technology, I use more technology oriented things. And to me, TOGAF is the perfect mix. And that's why 80% of companies actually use it that have a good enterprise architecture framework. How is the CCSK different from the CCSP? The CCSK is a very intro level fundamental cloud security architect exam. So, for example, if you were thinking like a CCNA, from a Cisco perspective, this would be like a CCNA. By comparison, the CCSP, or the Certified Cloud Security Professional, is like a CCNP. It's a much bigger, a much stronger, and a much more valuable certification. So a lot of people have asked me for a CCSK program. So many people wanted a fundamentals or junior thing to work with. And you know what? We did this here, but not only did we do it, I looked at the CCSK's IM things and I went, boy, this is a little weak. So I took some things out of, say, a CISSP level curriculum that I would do this. So what I did here is I supercharged the CCSK and I went to the fundamental element levels that no one would ever do to teach you what is a cloud, how are clouds designed, how does the compute infrastructure work. So I tried to give everybody a good starting point. And I would be thrilled if you would just do this, go through this 1 week of training, and then go straight into the CCSP if your goal is just certification. And I would take the CCSP exam, but I think this will make that exam a lot easier for you. So I'd do both, but I'd probably do the CCSP certification. But I think they're both great certifications, and either one would be good for you. Are there any free or reduced price CCSK text vouchers? How much does the CCSK exam cost? So I don't have any business relationships with the CCSK. I am teaching their course to help you. They charge what they charge. The course is approximately $445. What I will tell you is all the best certifications are not cheap. The reason the companies that do free certification vouchers and free exam retakes and all of this, the reason almost nobody is caring about their certifications anymore, for the most part, is because they know that anybody can pass them. And what happens is the exams that are more expensive, a CCIE, for example, which is say $1,300, but it costs $20,000 to prepare and pass the exam with all the takes and travels because you got to go places. Almost no one will take it. So over the course of say 30 years, there's less than 60,000 or less than 70,000 CCIEs out of the millions that have taken it over the years. So it's worth a lot. Same with the CISSP. It's an expensive exam, close to $1,000, but it's highly valued. So yes, this is a more expensive exam. And that's kind of why I said I would do this. And then I'd go straight to the CISSP and I'd get that big because it's a huge sledgehammer. But I would take this training and I would really build some fundamentals with it. And if you don't have a certain amount of experience and you're uncomfortable passing a CCSP-associate, then which is the same exam, you just don't have 5 years experience, then this is a really good certification to put on your resume. Must the cloud architect know a framework to work with, or must they be able to come up with the architecture by themselves? So Ngozi, let's be fair. There is no architecture for the most part. You'll design yourself. Most architectures that I work on take a team of 15 to 50 people. Now, the architect's job is to lead that team of 15 to 50 people to create something that's going to create either protect our clients with regards to security architecture or cloud architecture, which is enhance our client's business in somehow. So you're usually not going to be alone. Now, I will also tell you, Ngozi, that 70 to 80% of all cloud architectures are a complete and total waste of time and money, by the way. And what I mean by that is, Ngozi, and 70 to 80% of the time, and the statistics point this from both McKinsey and other providers, that businesses invest in a whole lot of money in tech and they get no business benefits. And that always happens when the architects start with the technology, focus on the technology, design the technology, and then leave. Because if you let's say you have two closets in your bedroom, Ngozi, and you took the clothes out of one of your closets and moved it to the other closet, which is what most people do when they go to the cloud. They either take their applications as is or they refactor their applications and move them to the cloud. But that doesn't change your life at all, and neither does moving your applications to the cloud. What changes, what provides that transformation is knowing what the business goals are, understanding the business architecture, working with that organization to find the best way for employees to work, and then finding out what applications and what services the employees need to be better at the job, what the business needs to do to be better at their product, service, whatever experience to get more clients to buy the product. And that never happens unless you start with the business side. So do you need a framework? No. But do you need to start with what is the goal and vision for the business? Yeah. What do you need to map out the business architecture? Know what the business architecture is. Map out that key business processes. Map out key value streams. Yes, if you want to provide any benefits for your clients. Do you need to be able to understand what the current technology architecture is and what it can do for the business, and then be able to create a new architecture by leading a team to be able to understand the business needs, the business goals, and the key business processes, and then work backwards to figure out what the new technology architecture is, and then what it takes to go say, oh, this is what we have, and this is where we need to go to. So what, can I do it all in a single step? Do I need to do it in multiple steps? That's the architect thing. Creating a governance structure, however you want to do that, is up to you. Creating a change management structure, however you want to do that, is up to you. Determining how the organization, if they have the sophistication, the readiness for change, the ability of people to handle your new architecture, that's up to you. So whether you use a framework or whether you just do these steps on your own, I don't care. It really doesn't matter. What matters is you know how to drive transformation. That's all that matters, and not be one of the 70 to 80% of the people that are designing things that provide no benefit. Because imagine this, you're a company and you waste $1 billion on technology and get nothing out of it. Now, if you save that $1 billion, you could have given raises to your people or maybe not done a layoff that year. So we have to think about spending the company's money wisely. And however you do that, and however you learn how to do that, as long as you do a good job, meaning get the client's results, really doesn't matter. But I follow a standardized process each time. Mike, please discuss some of the best options for data security in the cloud. What are the best encryption actions and access control? So Vivek, I've got a security architect program that goes through that, because data security, I can't answer that today. And I can't answer it today because it'd probably take me a week to properly explain data security. At least a week, because that's what goes into it. So I will tell you there's a lot about data security in this program if you keep waiting for it. There will be a lot, but understanding data security and data mapping and data classification and where you should store the thing, and do you need dissimilar systems and what kind of encryption you're using? Do you need hardware encryption? Can you use software encryption? What are you doing with regards to key management, label classification, data loss prevention strategies, which will also include things like network security, identity and access management while we're also at it, and many, many other things. So it's not something I can do in 10 minutes, but I will tell you we probably spend a day discussing data security in this program if you just give it and wait for its due. Hope that helps. Do I hire some of your students after the course, irrespective of their location? Absolutely. So I have Tyrone. He was a student of my course and he did great. And Tyrone lives in Cape Town, South Africa. I have Eddie, who used to live in Bamenda, Cameroon, but I think he moved to another part of Cameroon fairly recently. I have Chow, who's worked both in Vietnam as well as the United States for me. And now I have Leo, who's in Sao Paulo, Brazil. So they're my international people. And of course, I've got people in the United States, but of course I do. Any business would be crazy not to look throughout the international market to find good talent. There's almost no one out there that can do the job locally. But we search the world. There are so many smart people. There are so many people that are excited for the opportunity to work. Of course, I hire people regardless of their location. Okay, so If you're having a good time, give it a like, subscribe to our channel, and hit the bell to be notified of new videos to assist you in your technology career. As a reminder, a couple of things. We have a completely free ebook to go along with this. My team wrote it based upon the concepts of this course. So please sign up for it. It's completely free, and it will definitely help you with this exam. And I think you'll learn a lot just by going through the study guide. So please keep that in mind. On Thursday, 11 to 1 this week, it would normally be 1 to 3 p.m. We're running a How to Become a Security Architect webinar. Sign up. It's free. It'll be on Zoom. We'll go over the role, talk about what we do, talk about the skills you need, and I'll answer any questions you want in your career that we can to assist you. And it's all free. And don't forget, if you want to see some of these things demonstrated hands-on, there are labs for AWS, labs for Microsoft Azure, lots of networking exams, for example, and lots of opportunities in cybersecurity as well on our channel, CCSP, CISM. So make sure you check them out while you're here after this course is over, of course. Chris, let's go back to the content. In this video, we're going to begin section 2 or domain 2, which is going to cover cloud governance and strategies as part of the CCSK exam preparation. Now, in this section, we're going to focus on governance with an emphasis on security. And we want to talk about the need to align an organization's strategic needs with its business goals. And by aligning the needs and the goals together, we get that organization to its end state. Now, aligning strategy and business goals is going to take a lot. It's going to take various operational tasks and procedures, various tactical things. And the key to coordinate all of these resources is enterprise governance. Now, the ISACA defines governance as the following. Governance ensures that stakeholders' needs, conditions, and options are evaluated, setting direction, and monitoring performance and compliance. It says evaluates stakeholder needs and priorities, sets direction through clear action, and tracks the performance. Look, let's bring it to reality. If we're going to provide security for an organization that has 100,000 employees, for example, there is going to be a lot of moving parts. And you make one change of the system without understanding the impact to the rest of the system, you could just break something like that. So when we get involved in big and complex environments, we have to actually understand what we're working with. And that's the key for governance. So imagine you're dealing with a global enterprise. This is the basis of mostly what we do as architects, is deal with stakeholders. It's at least half of our job. So let's say we've got a giant company. And I want you to understand what we're dealing with in architecture, generally speaking. So this is a giant company. I mean, they're not big like Amazon with 1.5 million employees, but they're a big enterprise. So let's say 200,000 employees. Now, of this 200,000 employees, let's say we've got a appliance division, maybe, because these big businesses are in a lot of businesses. Now, they might not only have an appliance division, they might have a media company. They might make batteries while they're at it. You never know what you're dealing with some of these big enterprise companies. Let's say batteries. And they could also be making, let's say that they could be making medical devices. You'll see companies like this all the time. And then on top of that, let's add some like transportation thing, like an airplane engine. So now you've got a business, and here's your giant company. Now, each one of these businesses are slightly different operating in each business. And then each one of these businesses, let's say, have people that are responsible for sales, and that people that are responsible for marketing. And then they may have IT people in each one of these companies. Now, in order to truly understand what's going on, in order to be able to create an architecture, you have to find out from the CEO and the C-suite what's the vision of the business. Because if you don't know where the business is going, you have no idea how to optimize anything. Then the next thing the architect is always going to have to do, security architect, cloud architect, enterprise architect, we need to know what the needs of the leader of what these businesses are doing and what these businesses need to do to be successful. Because if we throw some security thing over here to fix something in the appliance division, but we kill the medical devices business, we're not going to have a job very long. So now we need to find the key stakeholders from these business units. And that could be the sales people, the marketing people, the IT people, the support people. So it's going to take a lot of knowledge to understand what goes on. And then this is just one IT department, but in that IT department, you're going to have application people that have application needs. You're going to have networking people that are going to be focused on the network. You're going to have AI people, for example, that are going to be here. And anytime any one of these people wants to make a change, it can impact this, which could then impact every other part of the business. Which is why architects, cloud architects, enterprise architects, security architects don't touch the technology. Because at least 50% of what we do is coordination of all of this stuff to make sure we meet the needs of the airplane engine people so we don't harm their business, to make sure that we understand the business's operations, to make sure that we know the way salespeople do their jobs so we can make it better and not break it with our security or our new applications. So this is why there's so much governance that we need. And now all of a sudden the application people want to create a new application and they want to deploy it. Well, the network people need to see if there's network capacity. The AI people need to make sure that it's going to work. The security people need to examine the impact of that new applications. So when it comes to change control, when it comes to change management, when it's going to come to anything, success is going to be based upon how good our governance is. Now, why did people go to the cloud in the first place? Well, they went there for cost efficiency. That didn't work. And the reason it didn't work for most people was because they went from a data center that they owned to a rental convenience data center where someone else had to build the same data center, pay tens of thousands of salespeople and solutions architects hundreds of thousands of dollars per year each, and then spend a fortune on marketing and advertising, have an army of lawyers and all this other stuff. It takes overhead to do that. So that's why, typically speaking, you're paying less overall difficult. It's simpler to rent a system, but it's typically not going to be cheaper. But what does cloud computing do? It gets us agility. We've got an idea. We've got a new application, a new thought for a new business service. We can put that on the cloud in seconds. I mean, seriously, that is fast. We need capacity. Boom. We want to do something faster than our competitors, get a first mover advantage. So lots of strategic innovation abilities. That rapid go to the cloud because so much of the work is done for you is so good for us. So cloud might cost a little more, might cost twice as much. And there will be times where that speed to market is going to be very valuable. That agility will be very valuable. So we need to create cloud governance programs. And I tried to show you the complexity to understand. And they will centralize and they will control all the activities in the cloud. Realistically speaking, we needed the enterprise level to deal with the things that are off of the cloud too. And that's what enterprise architects like me typically focus on, although I've spent a lot of time at the security networking levels too. I just love it all. So we have to make sure that the cloud services or whatever we choose meets the organization's business needs, their technical needs, their functional needs, and their security needs. And it's going to take a team of people to oversee that. Now, we want, in a perfect world, some way to centrally manage services so people can see it. Because what you're going to find in your security architecture career is if you do an assessment of an organization, and a cloud architect or an enterprise architect sees this every day, companies will have 1,000 applications and not even know about half of them. They'll be used 1%, but there'll be so many duplicative services. Now, by squashing them down, we can reduce costs, we can reduce complexity, and we can reduce attack vectors. Because if we've got 1,000 applications, potentially we've got 1,000, each one of them could be a source of an attack. So we also have to look for what's called shadow IT. So a lot of times in organizations, we may have a security control. And then we may have a worker that the security control makes their life harder, so they might create a workaround. Now, I've seen people bypass firewalls. I've seen people create all kinds of terrifying things to work around the need to get security to do something for them. And they created massive security holes in the organization. So we're going to have to be constantly looking around for people and look for it. In my youth, when I was when I was an engineer for the beginning of my career for a very short period of time, I thought my name should have been Sniffer Boy, because they were like, Mike, you go over there and sniff this. Mike, Sniffer Boy, go over there. And people even called me the Sniffer. Was what we used to call a protocol analyzer. And I kept plugging into the network all over the network so I could find stuff on the network, and you'd be surprised what we found. So we want to reduce or eliminate that shadow IT by understanding the right thing, creating the right governance, and getting people what they need so that they don't have to do silly things, or just blocking it if it's inappropriate. Now, we have to understand in the cloud, we lose control over their infrastructure. That is a complexity. We have to hope that they do their job. Now, we have to understand that we can't go in and audit a cloud provider either. We can't see what they have. So again, there's that. Now, we can look at audit reports that are publicly available, where a cloud provider pays an auditing company millions of dollars a year to audit the reports. And we can review the audit. Now, if you're the auditing company, is it in their best interest to produce a bad report if it's bad and not get the business of new consulting in the future? Probably not. So we have to trust the ethics of the auditors that are doing the reports on this for their quality. I'm not saying they aren't quality. I'm just saying we never know, but there typically may be a financial conflict of interest there. So some of these things that are complex in the cloud because you don't have complete control over that infrastructure. Some other challenges we have in cloud computing that we need to plan for are things like compliance and jurisdiction. There'll be in many cases, the cloud providers replicate their data to various parts of their world, and they do so for good reason to make sure your data stays that way. But you might be involved in a place where you can't let your data go somewhere else, and it may have to stay in your own country. So we can do that in the cloud, but that's going to be even more complicated when we have to deal with data sovereignty issues. So again, that has to be part of the planning. Whatever we're dealing with, we're going to have to deal with some risk assessment. We have to figure out what risks we're actually dealing with. And from there, we can figure out what we need to deal with. But we have to look at the risks. And we could have risk to data, we can have risk to the business, and we'll be always looking for certain things we need to deal with. Now, we can think about using cloud-specific security frameworks in our security architectures. And what do I mean by that? Well, there are frameworks that are out there. Things that we can think of that might work well for us are things like zero trust frameworks. For example, that we might want to use. There are some new frameworks that are coming out there with regards to ethical and technical controls for AI and machine learning. You're starting to see out there. So there's ways we can start to think about how we can control these things. Now, remember, in our data center, we can see it. With a cloud provider, we're stuck with third-party assessments. So we can't see it. Now, one thing we need to deal with and understand with regards to cloud governance is, what if things change on the cloud? We always have to be prepared for the unknown and the unknowable. So let's say we're in a cloud provider and we use the service and it's part of our business, and the cloud provider cuts it off. Gone. Dead. Now we might need a workaround. The other thing that we need to think about and always plan around is there were companies. I can think of one company in particular, the Parler, that went to AWS. They built a business in AWS. I can't say good or bad about the business. I don't know about it. But as soon as that business was there, AWS said, we don't agree with your business, and they kicked them out of their cloud. So I'm not here to make up commentary, good, bad, or anywhere in between, but every business has to perform what's called risk management. And there is a risk. What happens if you get kicked out of your cloud provider? What happens if you do something they don't feel isn't compliant with what they're looking for? So organizations always have to deal with what happens if a cloud provider were to do this? What happens if this provider were to do this? And that's one of the many reasons organizations hedge their bets on multiple clouds. So when we think about governance, when we think about framework, works, or whatever we're trying to do, we want to be as fast as we can, but we don't want to make errors. So we have to balance speed and risk control. And that's the point of using these frameworks. We have to make sure that decisions are made and the right people are accountable. And when we start dealing with frameworks and make sure who gets things what, it can put us there. Now, there's so many control frameworks. NIST is a framework. There's the ISO 27001 framework. There's a COBIT framework, for example, for program frameworks. There's control frameworks like the CIS framework, the CSC framework, the CSA CCM framework, the NIST 800-53. So there's different kinds of frameworks. And let's kind of look at how some of the organizations will make their policies and frameworks. I'm going to map it out for you because it can be a little tricky to when you first hear these things. So let's say an organization may have at the top level an information security framework. And this stuff is a little academic, but it's part of the CCSK exam, so we want to cover it. Now, in there, they may have an information security policy, which the security architects are typically doing a lot of. So let's just say this is the security policy for the IT policy. Now, under that, realistically speaking, we may have some additional objectives. We may need some cloud control, for example. Let's say some control objectives just for the cloud. So we may have some cloud security objectives. And you're seeing how these things are cascading in. Top level, we've got a framework, then we've got a policy, then we've got some objectives. And now this objectives, where are we going to take this? Whoops, didn't mean to go back there. So what if we have more than one cloud, which pretty much is like everybody. So cloud B, and then we've got a cloud A. We want to make sure that the same things are done, right? On A and B. So we need to use the same kind of firewalls in a perfect world, which means we're not using cloud provider firewalls. We're using some industrial thing we can put in both clouds. But might it be a different procedure to set up a virtual machine in cloud A or a different procedure in cloud B? Maybe. So what we're ultimately going to have to do is we're potentially going to have to come with procedures for each one of these cloud providers, controls and procedures for each one. I'm not really sure what I did with that. So I hope this is kind of starting to fit in that, at the high level, we build the framework. And I didn't make these up. Like I said, it's for your exam. And then there's a security policy. And then we're going to tailor that policy for each and every cloud that we potentially have to deal with. Clouds, private clouds, data centers, etc. So lots of things for us to think about. Which brings us into the world of policies, standards, procedures, and guidelines. Now, I know this can be another academic topic, but I'm going to do the best I can to make it simple. A policy is a broad statement of management intent. Everybody has to follow it, and it's critically important to cybersecurity in an organization because it requires all staff, all contractors to protect the confidentiality, integrity, and availability of all information and information systems. So everybody has to contribute to it. Typically speaking, there's a statement of ownership of this kind of information. Who owns it? It's possessed by the organization. It's typically owned by the executive, and this kind of thing comes down. Now, in the policy, there'll be this is the chief information officer, or who's the equivalent person. There's a delegation of authority to the CISO to create standards, procedures, and guidelines. So the policy is this big high-level thing. So think of a security policy as a formalized statement that comes from senior management. It outlines the approach to managing and protecting the organization and its assets. The security policy will serve as a functional document that will guide the development, implementation, and enforcement of security procedures and standards inside of the organization. It'll define the purpose, the scope, the roles, responsibilities, and management's commitments to maintaining security. The security policy will have a lot of things in it. There typically will be something related to data classification or how different types of data will be categorized based upon sensitivity and the level of protection they need. The security policy will typically talk about access control, outlining how to access information or how access to its systems is granted, managed, and even revoked. The security policy will deal with physical security, the protection of the physical facilities and the equipment from unauthorized access, damage, and interference. It will discuss network security and network measures and things that can be done to protect the integrity, confidentiality, availability of the information systems. Things like ACLs, IDS, IPS systems, firewalls, lots of things at the network. Probably half of what we can do is at the network. The security policy will discuss incident response, what to do in an incident, how do we detect it, analyze it, contain it, eradicate it, document it, all those kinds of things. And typically something that's related to legal and regulatory requirements is in our policy. Now, we security architects and cloud security architects are always working on security policies. A lot of our job is related to this kind of stuff. We may also have to create an acceptable use policy, which is going to be a document that we create to talk about how the systems can be used, how to use the system safely. It talks about what's good behavior to use the computer and what's bad behavior. And if users don't follow the rules, now there's a way they could face warnings, fines, or even prosecution. So it's all based upon if you work for the company, what they could do if you damage somebody else's systems. Now, a policy typically has to have a fairly large approval process. It could start with the security architects going to various stakeholders, and it could ultimately have to go to the CEO. Although sometimes the CISO can often do this as well. Now let's talk about a policy, about standards. So policies are big and broad. What's a standard? A standard is going to be mandatory requirements detailing how an implementation of a security policy is going to occur. Policy, big, high level, standard, pretty much, how do you do it? Now here we might have specific configuration settings for common operating systems, like a common build, for example. We might put in controls for highly sensitive information. We'll put in other security objectives as well. Now, getting this thing approved, standards isn't going to be quite as hard. It's going to be approved at a lower level than a policy. We can change standards more frequently, and we may have to. And organizations can develop their own standards. They can adopt existing standards or even modify other standards to meet their needs. Okay, so policy, super high level. Remember, standards are kind of the mandatory requirements of how you're going to do it. So what's a procedure? A procedure is a step-by-step set of instructions for a specific situation. And that way it ensures that everybody follows a consistent process to achieve the security goals, and compliance is mandatory. So those are the main kinds. Now, you will see, we're going to talk a little bit about policy frameworks. And they're going to be for lots of reasons. We may have procedures on how to monitor our systems. And this may describe how security monitoring activities will be performed. It may include things like continuous monitoring technologies. Policy frameworks may also include evidence protection procedures. So we may need to talk about what to do in response to a subpoena or a court order or legitimate request for digital evidence. We might talk about patching patterns or have something to talk about how frequently to apply patches and even how to patch the systems. Now, the last thing we can do is talk about guidelines. And guidelines provide best practices and recommendations for specific concepts. Again, compliance will be mandatory, but these are more helpful advice. So is this helpful advice optional or is it mandatory? That's going to determine at the organization. But guidelines are sort of best practices or recommendations. So the key, what we're trying to do is we're trying to translate some kind of a guideline into something actionable that needs to be done. And we want to make sure that whatever we're doing is we're making sure that organization adheres to any regulatory and compliance issues. For example, if it's in healthcare in the US, it needs to apply to HIPAA. If it accepts payment cards, it needs to comply with PCI DSS, for example. Let's talk about best practices and contractual frameworks. So, things like this. So the cloud providers themselves do provide well-architected frameworks. Now, here's what these frameworks do. The cloud provider says, here's how to design our systems, and here is how to secure our systems. All in all, these things are great. But let's talk about the challenge you'll see when you use these systems. First, these frameworks have complete and total recommendations without even knowing the customer's needs. So recommend use managed services, for example, whenever possible. Maybe that's right or wrong for the customer. You won't know until you ask the customer. So there's one thing that you're going to have to deal with the cloud providers frameworks is they're pre-made for the average customer, not your particular customer. The second thing is many of the types of things that they would recommend in these frameworks are going to work beautifully in a single cloud environment. But in 98% of cases, we're at enterprise level, we're not dealing with a single cloud environment. So we can take certain things from these frameworks that are great, like the cloud providers frameworks, but we're also going to have to use key other frameworks, which is why we've talked about other frameworks. Now, whatever we do when we create an architecture, we need to make sure, or whatever we're dealing, we get the right people in board. Remember, I showed you earlier in this video the cloud architects coordinating and the security architects with various stakeholders. The key in order to find business needs is we need to know the vision from the C-suite. We need to learn about the current systems and challenges from the IT department. We're going to need the security team to understand what's been going on security-wise, physical-wise, IT security-wise. We may need to talk to lawyers and compliance people. We'll be talking to the finance department, the business leaders, the operations team, project managers, and vendors, and so many things. So part of security architecture is going to be pulling all these things and coordinating and facilitating them. So that's the basis of what we're talking about. There are some things that you always want to think about. There's lots of frameworks that exist out there, but really what we're talking about is finding a way to come up with a structured way to approach everything the same way every time. And there's about 17 control domains that cover governance, risk management, operational security, and what we're talking about all in all to get into cloud security. And throughout this training program, we'll talk about various ways to enhance the security of our organization. Okay, so we are back and we are here to answer questions. So let's do it. Let's see what questions are there. As a reminder, if you're just joining us, we have a completely free e-guide to go with this. My team made cheat sheets. They're several hundred pages long. They're fairly comprehensive cheat sheets, so please download them now. And we look forward to seeing you. And we look forward to you actually having these to help you with the exam as well as your study in cybersecurity, security architecture, cloud security architecture, or whatever the careers that you're actually looking for. So it's free. If you're enjoying the content, please give it a like, subscribe to our channel, hit the bell, and tell others that you think would benefit from either free training on security, cloud computing, or networking, because we really wanted to help as many people as we can. Now, Chris, please bring, and of course on Thursday, we have a completely free webinar on how this week is going to be on how to become a security architect or a cloud security architect, and it's going to be at 11 a.m. Eastern Standard Time for 2 hours. Well, we'll go over the security architect role, what we do, the skills you need, and it should be a good time. Chris, let's bring in the next question. Frameworks, policies, and standards. So it helps you see the order. So here's what I really want you to think. A lot of the frameworks out there are overarching security ways and things to consider and steps to take. The most important thing we have to figure out is the policy. What do we need to do? What are we protecting? Where are the weaknesses? How are we securing them? Who needs to do what? What is acceptable use of our systems? Because that's going to be the most important thing to figure out. What do we need to achieve? Now, sure, we might take frameworks and other regulations into that when we design our policy. For example, if it's protected healthcare in the US, we're going to focus on HIPAA. If we're a business dealing in the EU, yeah, we're going to work on the EU privacy standards as well. But think the first thing you need to do is create the policy. You'll need input and output from various frameworks on how you're going to secure the systems and potentially even your architecture. But I think start with the business. The business is the policy. And then when you think about standards and things are more best practices and procedures are more about how people do as something that you need to do. So think of them as different things, but how they all are going to work together to get you to the goal of security. Who else has questions? Wow, I'm either doing a really great job and everything is so easy to understand, or you are all being shy. And we would do one out. So we'll wait one more minute to see if any questions pop in. And if not, we'll get back to the content because I'm having fun. Are you all having fun? If you're all having fun, give me a hashtag CCSK or a hashtag security or cloud security or security architecture or whatever it is, because I love this stuff. I live for this stuff. Ever since I left healthcare 25 years ago, my whole life has been about architecture. I just love it. Hmm. All right. I don't see any questions coming in, but I see a hashtag CCSK. I'm very happy with the hashtag CCSK. Maybe it'll help others find this free certificate of cloud security knowledge trainings with in preparation for the CCSK exam, plus a lot of fundamentals on security architecture and cloud security architecture. So thank you so much for the hashtags of the CCSK. Love seeing it pop in on the screen. Love seeing it in the chat box. And I guess we didn't see any questions, Chris. So why don't we go back to the content? I want to. Oh, well, now two questions popped in. Okay. Chris, I see a couple questions. You're in a SOC analyst now. Can you work to be an architect with training? Being a SOC analyst is very different than a security architect job, but of course you could. But, it has nothing to do with your background. Jordan Kay was a college student who got his first job at AWS as a solutions architect. Uh, Coyote, again, was a college student, got hired by AWS as a solutions architect. While we're at it, Richard F. got hired by MUFG Bank as an architect with no background, but we trained him, so it didn't matter his back. Now, Jeffrey W. Jeffrey was a geologist, but got hired at Kalian as a solutions architect. That's his first background. Richard was on TV and nothing related to technology, but we trained him and he got his first role over in some environments that's so secure as a security architect in some CISO's office, but I can't actually talk about it. But of course you could. So it really doesn't matter. Noah was a 24-year-old who got hired at North Highland as an architect. Pierre was a sailboat operator hired by LeaseWeb in Canada as a solutions architect. Emmanuel was just hired as a cloud architect over in England. It was his first tech job. So it doesn't matter what your background is. What matters is will you develop the skills and have them. So join us on the webinar on Thursday and I'll assess your skills if you want. I'll tell you if you're ready to be hired or if you need to learn architecture because the roles are very different, but we need people in all roles. So hope that helps. But of course you can. So what is the role of governance, resource, and compliance in a company? So the governance resource, so what we're talking about here is from a governance perspective, we're making sure that the company has a way to make sure that things are implemented. So if you want to make a change on the system, for example, the governance structure will have to evaluate the change. The governance structure is typically the leadership of the organization. Now, let's talk about compliance. Let's talk about regulations and compliance. Businesses will be subject to regulations. Healthcare is subject to HIPAA. Banks are subject to Sarbanes-Oxley and about a million and other things, for example. All businesses could be subject to types of regulations. So what do businesses do? They have a governance, regulatory and compliance team. Now, typically they're staffed by attorneys, which are going to run this because they're going to be the experts on regulations and how to adhere and comply to these regulations. But there'll be people that are focused on the regulations, and some people will be cybersecurity professionals, and some people will be attorneys. I don't typically recommend going down this path for people that are not attorneys because there's so much involved in law and understanding the law and being able to know how to circumnavigate the law. That's why these roles that typically at the top level or anybody that's going to be paid well in these roles is usually an attorney. So They are good roles for people that have the background. There are some not attorneys that understand the things from a security perspective, and they're also there. But at the top of that food chain is always going to be the attorneys, where, when it comes to tech, some of the biggest opportunities, for example, might be in architects, where they get paid a lot more than GRC folks. And because they're more focused on business enhancement. So you can think of your GRC folks as your people that you have to pay. They're a total expense to you to make sure you comply with regulations. And organizations understand that, and they pay them according to that. Versus a security architect, let's say you worked for, say, Cisco, where you might be going out there and selling $500 million a year of security architecture products and solutions, bringing money in. So that's the role of governance, resource, and compliance in a company. And also the career aspect of it as well. Chris, let's go to the next one. How is policy that's different from standards? So here's the policy. I'm the CEO. At Go Cloud Careers, this is what has to happen. We need to make sure that everything is done. These are what you have to follow. Now then, once we go from the policy, we may talk about standards or how you might do a certain thing, or what are the best practices for certain things. How would you secure a certain thing? How would you repeatedly do so? And that's more of your standards. More recommendations, whereas policy is mandatory from the top down. Good questions here. Is there a difference between a solutions architect and a cloud architect? Generally speaking, yes. So when it comes to architect jobs, the bottom in terms, typically speaking, of pay and the most entry level is the solutions architect. Now, the solutions architect typically works for a single company and designs, presents, and sells single company solutions. So, within 2 years, I was a principal solutions architect because it's a very entry level role. That's why so many people we train, it's their first job as a solutions architect, because we prepare them to be cloud architects. And if they can do that, being the solutions architect, easy. So you can think of the solutions architect as someone that worked for AWS, that'll design, present, and sell you an AWS solution. You can think of the cloud architect by comparison of the person that's going to design the solution across the Nutanix cloud and the data center, the AWS, Azure, and Google Cloud. And you're going to be creating disaster recovery policies across clouds, these really critical high availability environments. As the cloud architect, you're going to be dealing with reality, which is multi-clouds and hundreds of applications, for example, and huge networks that probably have 10,000 routes in the routing table and 200,000 IP address and locations in 50 different countries. That's the reality. That's what the cloud architect's going to be focused on that. So, keep that in the back of your mind. The solutions architect is a very basic role. The bigger architects, like the cloud architects and the enterprise architects, are trusted advisor roles. People are paying you for your expertise. Solutions architects, they're not as trusted as you'd want them to be, because typically speaking, in a solutions architect role, you get paid some kind of commission or bonus based upon sales. So you're incentivized to sell. So I've been a solutions architect, first job I ever had in my life, basic entry level. And then after that, I moved into bigger roles, cloud architect, for example, enterprise architect, and they were great. By comparison, a security architect is someone who focuses on security, which is more of a specialty than the global cloud architect that's focused upon everything. Hope that helps. You didn't realize this was an entry level position? How about a security architect? So I call any position entry level, and here's the reason. Do you know what a physician's first job is? A physician. You know what they don't do? They don't work as an emergency medical technician and then become a nurse and then work as a nurse for 50 years. And someday they're a physician. Their first job is a physician. Do you know what an airplane's pilot first job is? It's an airplane pilot. So, when I trained for my career, I started out as a senior engineer, and 3 months later, I was a principal architect. It was just the way I ran my life. It's what I trained for. So any of it can be training. I mentioned Pierre was a sailboat operator. Al was a sales rep, but he got his first job as a senior solutions architect at Deloitte. Noah was a social worker, but he got hired as an architect at Ahead. So it doesn't matter where you start. Glad I was a project manager and then moved into a cloud architect role. It doesn't matter where you start. What matters is, do you have the skills? Most people, they become an engineer, they spend 10 years as an engineer, and then they apply for an architect. And here's the thing. Engineers and architects are so different, and in most cases, I've got someone with 10 years of security engineering experience. It takes the same 1 year to turn them into a security architect as it did if I had a sales rep, because the jobs are so different. When we look at architecture careers, let's say there's 1,000 things you need to know how to do. Collect information, lead a team, sell, what have you. Design and architecture, lead a team, give presentations, respond to RFIs, RFPs, RFQs. What if I were to tell you out of the 1,000 skills, a sales rep comes in, typically speaking, with about 100 to 150 of them, and an engineer comes in with about 10 to 20 of them on average? So it doesn't matter your starting point, it all matters what you learn. And do you have the right skills? And can you do the job? Do you have the right attitude, energy, enthusiasm, passion for the work? You willing to go above and beyond? That kind of thing, that determines what jobs you get. We'll talk a lot more about it on Thursday, since you said you were going to join. I really want you to know exactly everything you need to know, because I think the security architect career is the best career right now, one of the best, along with cloud architect, enterprise architect. The average security architect earns $229,000 per year, according to Glassdoor. Feels a little low to me, but the range is about 200 to 300. And the security architects, for example, with better skills, enterprise architects with better skills, cloud architects with really good skills, with executive things, you could be dealing with $500,000 or more easily. So it all depends on where, but most people start out as like a solutions architect, but could be a security architect like Delroy Batt, or like R, for example, or Michael was a security architect, but he was a sysadmin before that, and we trained him. It doesn't matter your background. You can easily get there. Great questions. All right. So let's get back into the content. I want you all to have some great time, learn a lot about cybersecurity, increase your fundamentals. So let's get back to the content, and I'll see you in about 20 minutes or so. Now we're going to begin Domain 3 of the CCSK exam, Risk, Audit, and Compliance. And this is one of my favorite topics in security, especially for security architects and cloud security architects, because if we don't know what we're protecting, we have no idea how to design a secure solution. So this is pretty important. So the focus of this area is, how do we manage or reduce risks and make sure our organizations kind of get to whatever they need to, goal-wise, regulatory-wise, etc. And that's what we'll be talking about here. So organizations have risks. They have a lot of risks. They have risk from cybersecurity, and they have other risks as well. And the key that we have to deal with is, when we're protecting an organization, we're protecting them from many things. We're making sure their systems are up and operational so the people can do their jobs. We're making sure data hasn't changed in the system, for example, so the organization operates on good data. We're making sure the system's privacy is there, that the systems are the way they're supposed to be, and so many other things. We're protecting the company, we're protecting the people's jobs, and in some cases in security, we're actually even protecting life. So organizations have a lot of things that could occur if they had a security event. There's the potential for damage to the organization, challenges to the organization's operations, damage to the organization's brand, and so many other things. So we're going to be talking about that, and that's in this section. And we really need to think about risk management as identifying the risks, assessing the severity of the risks, and then figuring out a way to manage the risks. And that's really all security really is, in some way, shape, or form. So we're going to be going over a few key terms and a few types of points of knowledge, so you understand how to speak the same language as others, and then we'll teach you how to calculate risk, which is always interesting. So one of the things you need to think about in security is we have certain things called threats. And a threat is an event that might impact the system in some way, shape, or form. So the threat of someone breaking into the systems, stealing the confidentiality of information, or stealing a secret formula, or damaging the integrity of the system, that's a threat. Now, a vulnerability is a weakness in the system. So weaknesses can often be used to attack the system. And a threat might exploit a weakness. And then risk is really when basically somebody exploits a threat. That's the risks. Like, what happens if somebody breaks in? What happens if somebody steals the data? What happens if someone steals the secret formula for a new drug for a drug company, or a new GPU for a GPU manufacturing company? So we have to understand that there's a cost to these things if these things occur. So with risk management, we have to identify any of the potential problems that can threaten the organization or the business, and then we have to determine or its assets. And risk management will determine whether the cost of solving it is worth it, or maybe the cost of solving it or mitigating the risk could be done by transferring the risk or other concepts, which we'll talk about later. Whatever we're dealing with when it comes to risk management, we're here to design effective strategies to help an organization mitigate their risk as best as we can. And this type of an approach of figuring out what your challenges are, figuring out what the risks are, and then figuring out solutions is how you protect an organization. So let's talk about the first round of risk management, because that's going to lay the foundation. And then obviously we'll do repeated rounds of risk management to make sure that we're constantly protected, especially as things change inside of our organization. But the primary goal of risk management is to reduce the risk to an acceptable level for everyone involved. I'm going to make it clear, it's never possible to get to a zero risk situation. Never. There's always risks. But what we're trying to do is mitigate the risk to an acceptable level. In many cases, to make it too hard for people to actually hurt us, that it's not worth it for it, because we don't have enough to offer. And we'll talk about what that might mean. For example, if you have $1 billion asset and it's going to take $10 billion to get the $1 billion asset, it's not worth it. So that's generally the goal, is to make it infeasible or cost infeasible for the people to break into our systems to gain whatever we have to protect. So we're going to divide risk management into risk assessments and risk responses. And we're going to talk about risk assessments or risk analysis. What goes into it? Well, first we have to examine the environment for risks. We're going to have to evaluate every threat that could occur and the likelihood of these threats occurring. And then we'll ultimately have to assess the severity of damage should one of these threats be exploited. And then we're going to also have to figure out what are the cost of countermeasures for every risk. No, the way we respond to the risk could be we're going to evaluate countermeasures or safeguards that we could use, or even a security control. And then we'll use a cost-benefit analysis of risk mitigation approaches. And after that, we'll look at our findings and see what we can do. We'll have based on various concerns, priorities, or even resources that we have. So we first need to know what we have. What is it that we're protecting? What are the assets? And let's talk about the kind of assets a business could have. A business's assets could be its physical buildings. Some companies own lots of property, and that is considered an asset. But typically in cybersecurity, we're talking about these kinds of assets. So think about the source code for a brand new multi-billion-dollar application. That is an asset, and that's got a lot of value. Even if it's intellectual property, it's got a lot of value. Think about the research and development for a new breakthrough cancer drug that could solve 25% of cancers. Again, this secret formula might be worth tens and hundreds of billions of dollars. So that is an asset that we would often have to protect, and protect quite severely. An organization's data and an organization's strategic forecast. Oh yeah, that's an asset. And there are businesses that have such a good proprietary business process that gives them a competitive advantage over their competition. That too is an asset. And these are the kind of things that a business might have. So you have an asset. How are you going to know what to protect it? Do you protect a $1 asset the same way you protect a $10 billion asset? Absolutely not. So we need to determine what is the value of what we're protecting, to determine what the risks are, to then determine what's an appropriate level of risk mitigation. So we're going to have to think about this, because photos of my cat Cindy, and I love my cat Cindy, they're just not worth that much to anybody other than me. But if I had a secret formula for a new drug, or I had the new GPU that could be 10 times faster than anything else that was out there, that would be a pretty big asset that would take a whole lot of perspective. So we have to determine what is the value of the asset. Now, how do we determine what's the value of an asset? Well, there's a couple ways we can do it. Let's say what would be the cost to either purchase the asset or develop the asset from scratch. That's one way we can consider the asset's valuation. We can also consider the asset's valuation by what's the value of the asset to the business. If it's a pharmaceutical company and they've got a new secret formula for some brand new drug that's going to be huge, that might be the only thing the business has going for it, and that might be the most critical and strategic thing for that business. Likewise, it could be some little small thing that's not insignificant to the business. We also have to think about what's the value to the competition. So let's say a prominent GPU maker, the number one GPU maker, has a new formula for the best new GPU for AI. What would be the value if the number two GPU manufacturer got that architecture and got that design and was able to do something with it ahead of time? So, that's another thing that we need to think about. We also might think about what's the intellectual property value. That source code, that special asset, what's going to be worth in terms of sales, what have you. And we also have to think about what kind of damage to the brand will occur if an asset is lost or compromised. You got a car company and they're known for their new fancy car, and all of a sudden they stop producing that car or can't produce it anymore. What's the damage to that business? So we have to understand asset valuation. Now, that's some of the ways we can get to the actual value of the asset. And then we have to think about the threats or the potential events that could result in some kind of undesirable consequences to the asset. And then we need to think of actions or indicators, interactions that could cause harm, loss of the asset, a disclosure of the asset if it's intellectual property, for example, or privacy. And we need to think about all these things. What's the risk? What's the route? What would it take to get access to these things? So if we look at key aspects of threats, they can be deliberate, meaning a hacker could try to be doing it, or it could be innocent. For example, a person at Google that was working there deleted a client's $240 billion hedge fund. That was an accident. Someone took down Facebook for the better part of a day because they made a BGP mistake. That's an accident. That is unintentional. But there are people that want to steal secret things or break in and destroy the businesses, and that's deliberate. Attacks can come from inside, and often do, often by accident, especially if the controls aren't tightly there, but sometimes deliberate. And the attacks can come from the outside. So let's think about threat actors. Now, a threat actor is going to be something or someone that intentionally tries to exploit the system. Now, this could be a person trying to exploit the system or a system trying to exploit the system. We can talk about threat vectors, and this would be how the systems would be attacked, the vector, the way the system could be attacked. And, it could be attacked over Wi-Fi, maybe attacked over an email, or a worm plugged into a USB port. How did the attack occur? What's the vector? What's the way that the attack could occur? And then the vulnerability obviously goes back to system weaknesses. For example, we might have an unpatched operating system for which we know there's vulnerabilities. Or we could have a weakly designed demilitarized zone for the web applications, and that could be a big vulnerability to the system, for example. And now we need to think about exposure. And exposure is going to be the risk of a loss that we're dealing with. So doesn't mean the expense has to occur, but it's knowing what harm could actually occur if so. So if our systems were broken into and they got the secret formula, that's our exposure, and that's exposure the kind of risk we need to manage. So let's talk about risk as the chance that a threat will take advantage of a weakness in the system and damage something valuable. So if you think about the risk, let's say we've got a secret formula for something, and then somehow we had a weakness in a system, and an attacker attacked that weakness, broke in, and stole our secret formula. That's the risk. Now, the greater the likelihood of this kind of negative event happening, even the greater a risk. So if someone tried to hack you once every 10 years, and you can successfully defend most of the time, 99.999% of the time, you're doing pretty good. But if people try to attack you 100,000 times a day, and there's organizations that people try to attack them 100,000 times a day, that wouldn't be good. They need to be able to mitigate more attacks than that most of the time, or something to that effect. I hope you understand my point. They need to be able to keep those systems up and operational. And some organizations have a big, huge risk. For example, if you were a hacker, who would you hack? A mom and pop business shop or a cloud provider? which may have tens of thousands of customers or hundreds of thousands of customers on that cloud provider. The cloud providers also have incredible risk mitigation capabilities because they know they're the highest value targets in the world. Hack them and get maybe tens or hundreds of thousands of customers' data. So we have to think about how often the attacks are trying to occur. So basically, we're going to do some risk calculations, and I tend to think these things are fun. And if any of you have an MBA, for example, or went to business school, and you ever had to calculate the expected value of an opportunity, we're going to be dealing with similar calculations right here. Now, you can think of the risk as the probability of harm, which is going to be in a percentage, times the severity of the harm. So what do I mean by that? What I mean by that is if, for example, you have $1 billion asset and the risk of the $1 billion asset being compromised is 10%, your risk is $100 million. That's your actual risk, because your risk is the probability of harm in a percentage by the severity of harm. So 10% times $1 billion equals $100 million. And this is typically how risk would be calculated. So what we're going to want to do is find some safeguards or security measures that are going to reduce that risk. And that's typically what we do in security architecture. We come up with policies, guidelines, procedures, architectures, incident response procedures, and any type of design that we create to reduce the organization's risk. And I want to make sure that you realize that implementing safeguards to reduce the risk doesn't have to cost anything. Sometimes it does, and sometimes it doesn't. There are organizations that have private clouds, and they've got routed networks where they could put more access control lists on the network. They could implement quality of service to make sure bad traffic doesn't take over their network. They can do micro segmentation on the routers and switches that they already have, that they've already paid for. Things like private VLANs and layer 2 access control lists and all kinds of things. Admission control into the systems. In many cases, the organizations already have the devices there, and they just have to turn these features on. In other cases, it might be slightly moving the way a design is. And in other cases, it's going to involve the purchase of quite a lot of software, hardware, or anywhere in between. So we have to think about the entire thing. So an attack is going to happen when someone deliberately tries to take advantage of a weakness in the system, because they want to steal, cause harm, or expose something valuable. An attack is any action that's going to go against the company's security risks. And even if the attempt doesn't actually break through, it's still considered an attack. So if you try to break into a building and don't, it's still an attack. You could still get arrested for trying to break in, even if you're unsuccessful. And that's the concept here that I want everybody to understand. An attack is when anybody tries to do something. It doesn't necessarily mean they got in. Now, a breach, by comparison, is I tried to break in, I broke in the front door, and now I breached the property. That's a breach, and it's the same thing in cybersecurity. A breach is going to be an intrusion or a penetration or anytime something gets into the system, and that's what we're talking about. So a breach isn't an attack that was successful. Now, we're going to start getting into the numbers of risk management. We'll get a little geeky here, but I'll make sure it's pretty easy for you. And we're going to have to come up with a quantitative and a qualitative assessment. The qualitative assessment, realistically speaking, is if something were to occur, what's the impact to a business? So, for example, let's say we're a business and we were to be hacked. What damage would that occur to our brand? Let's say we all work for the same business. Might not be good for us. Now, imagine a security consulting firm that was hacked. That would be pretty bad for their brand, right? So that's the kind of qualitative things we're talking about. If we all work for the same security company and the security company would be hacked, that would not make that company look very good. And then people might be less likely to buy our products and services, and that could be very harmful to the company we all work for. So these are soft qualitative things that are hard to know, but we still need to calculate because there is a cost to the company. Now, there are other things that are very easy for us to calculate from a risk management perspective. We're going to talk about that. And it's going to be absolutely critical to quantify the risk. First, you're going to need to get budget to mitigate the risk. And you're not going to get budget unless you can show someone that here's your actual risk, and see, here's the cost to mitigate that risk. And it costs a whole lot than the actual risk. You do that, you won't have any problem getting your cybersecurity budget. And, good security salespeople, good security architects, really good cloud security architects, and any architect for that matter, has to be able to convince the client to spend money and invest in the right solution. And truthfully, great engineers need to be able to do this too, because it doesn't matter how good the recommendations are if you can't get the company to pay for what's needed to actually solve the problem. And that's going to come from your quantitative risk analysis. So we need to talk about that. And what's going to go into the quantitative risk analysis is going to be several things. And I'll walk you through the process. Basically, we're going to have to calculate the asset's value or figure out what the asset is worth. Then we're basically going to have to figure out what is the risk or likelihood that asset's going to be hurt, or destroyed, which is going to be the exposure factor. And then we'll calculate a single loss expectancy for a single asset. And then we'll figure out how often a compromise would occur. And then we'll do this for every asset we have. And then we'll have that organization's risk, otherwise known as its annual loss expectancy. And it sounds kind of complicated and scary. And I'm not Mr. Math, but I promise you this is very simple math, and it will be no problem to work with. So let's first talk about the asset's value. Because if we don't know what we're protecting, then we have no idea. So we have to determine what is that asset actually worth. And what is it worth to the business? What is it worth to secret formula? That's the first step. What is the asset worth that we're trying to protect? And once we know that, then we can figure the risk of that asset being compromised. And that's going to be typically in a percentage. So the risk of something happening is going to be called the exposure factor. And that's going to be either calculated from statistics, based upon previous events, for example, or from maybe the industry knowledge or consulting projects. So imagine a company like a Accenture, Deloitte, KPMG, Capgemini, PricewaterhouseCoopers. Consulting firms like those have good data on specifically speaking on the risk of assets being compromised based upon clients they've worked with through the last several decades. They have good information. Big tech companies often have this kind of information because they're constantly looking for statistics. They're constantly consulting with clients. And a company like a Cisco or an IBM or a Microsoft is typically going to have very good statistics. Other companies would too, but big architecture firms typically have a lot of good data here. So you start getting this kind of information, and then you can calculate the risk that you might see on that. So if we've got a $1 billion asset, and we've got a 10% risk of exposure to that asset being destroyed. And guess what? Here's how we're going to calculate it. It's going to be relatively easy. So what we're going to calculate is the asset value in dollars or pounds or whatever is useful in your country, or euros, for example. And then we're going to calculate the exposure factor. So if the asset value is $1 billion and the exposure factor is 10%, that's $100 million. Now, you do that for $1 billion asset, and you've got $100 million risk, and then you've got a $20 million security solution or a security architecture. People are going to be pretty excited about your $20 million security architecture. So it's really about the potential total loss, the potential amount of loss that could occur if an asset would be harmed based upon a single threat occurring. Now, we want to talk about that annualized rate of occurrence, and that's how often we think something is going to happen in a single year. So there may be things that happen 10 times a year. Well, then that annual rate of occurrence would be 10. Maybe it only happens 1 every 10 years, and that annual rate of occurrence will be 0.1. But again, this is the kind of information we're going to get from statistics. And or consulting firms or consulting projects. So if we go back to what we're actually talking about, you can see we started with the asset's value, then we got to the exposure factor, then we calculated that single loss expectancy by the asset value in dollars, and we multiplied it times the exposure factor, and now we're getting this annualized loss expectancy that we're typically dealing with. And which was ultimately going to get us to. But all that has to come with the actual annualized rate of occurrence, which is going to be the frequency that we think these things are going to occur. So I just want to make it sure, because a lot of people think this is complicated initially. We know what the risk, what we have, and what it's worth. We know the risk of it occurring, and that gets us the single loss expectancy. And then we get to this annualized rate of occurrence, which is going to be the expected frequency of a specific threat occurring in a single year. Now, once we get past that, that gets us into our annual loss expectancy. And our annual loss expectancy is the possible yearly loss of all instances of a specific threat if they were to occur. So how do we calculate the annualized loss expectancy? Well, it's going to be the single loss expectancy that we talked about first. That was that first calculation times the annualized rate of occurrence. So what that math formula is going to look like, it's going to look pretty similar, and I want you to see what it looks like in front of you in case you're a visual learner. That annual loss expectancy, or annualized loss expectancy, is our single loss expectancy for each thing that we've done, times that number of times it would occur per year. And these are the basic calculations that go into risk management. So what do? We run these same calculations on every asset the organization has. We go through that same process. You can see, this could take a lot of time for certain people to do these things. And that's why we have teams, specifically architecture teams, for these kinds of reasons. So these findings need to be figured out. They need to be documented. The risks need to be ranked in order. I'm going to tell you why. So it'll never be possible for an organization to mitigate every single risk they have. It'll be financially impossible. And honestly, physically impossible anyway. So what an organization is going to have to say is, we've got all these risks. Which risks are critical? Which are the biggest risks? And prioritize those risks. So we have to figure out and help an organization, especially as a security architect or a cloud security architect or a CISO or any cloud architect or any enterprise architect in general. What are the biggest things we have to fix right now? Let's fix them. And which risk can we not fix, or we need to solve another way? Okay, we are back. So we're back at this point. Let's see what kind of questions exist. There may be some. I think some came and I actually answered with a personal account, not even the correct account. So Chris, bring in some questions and let's see what we have. But before we do, I want to remind everyone that we have a completely free guide that goes along with this book, along with this course, to help you pass the CCSK exam in order to pass that CCSK certification. The training we're providing here is for the newest version of the CCSK certification, the CCSK V5. So make sure you ask your questions. We want to do anything we can to get you to your goals. On Thursday this week, we have a How to Become a Security Architect webinar. It's going to be 11 to 1 Eastern Standard Time. Chris from my team will drop the link of that in the chat box. He just dropped the free companion guide. And Chris, bring in some of the questions we're getting. CCSK and AWS SAA will be good enough. Was looking to the CISSP. No, it won't be close to good enough for anything, any career. So it depends what we're talking about. For example, when I train a security architect, I teach them the network, the data center, and the cloud, and how all these systems are designed. And then I provide security training, how to design an architecture, what goes into a security policy, all those architectural elements. Then I spend a lot of time discussing the things like the Zero Trust framework and the NIST framework and how you would do that. We get involved in all the security architecture things and that you might need to know. Then the certifications we teach are the ones that matter first, that really look big. So we do the CISSP, the CISM, and the CCSP. And then we would typically add an AWS Solutions Architect Professional or an Azure Solutions Architect Expert or a Google Professional Cloud Architect. And we provide the training for the AWS and the Azure one. And the Google one is coming in about a month or so because you need to know those as well. So I'll talk a lot more about certifications. Generally speaking, associate certifications to a manager mean you're almost ready to be trained. And then with the professional certification usually means you probably know something and I should interview you. but understand the certifications will never teach an entire career. I spent 1,000+ hours training a security architect. I spent 1,000 hours training a cloud architect to get them hired. The AWS solutions architect professional is about 25 hours of training, and the CISSP is about 40 hours of training. So that would only be 65. So we're talking a career like a security architect, where you're going to get paid, $250,000 as an average. And if you're really good, earn three, four, and $500,000, you're going to have to know a lot more. So what we're doing here is a great intro to cybersecurity. And we're teaching more here, much more than you would get about security than in an AWS of Security Advanced. Far more, probably double or triple the amount. So we're giving you a very good introduction here, but you're going to need much more for a security architect role. Of course, you can bring in the next one. I know it's probably hard because I answered in the wrong box. So, Mike Gibbs, you were drawn into governance, regulatory, and compliance, specifically PCI DSS, and now you're seeing what a cloud architect can do and can become. You want to combine them. So, the reason I asked you if you were a law degree, if you had a law degree, is a good architect's pay is going to be $3, $4, or $500,000. A governance, risk, and compliance person is going to be $100,000. So by trying to add the governance, risk, and compliance into an architect job, you won't be able to do architecture. All you'll do is governance, risk, and compliance. And unless you have a law degree, you're going to be capped at $100,000 or $120,000. So here's the reason why. So cloud architect is designing a solution to optimize business performance. So let's say I've got a global retailer that's doing $20 billion in sales. What if I could tune that website by a way to just give them an extra 0.5% revenue by improving the customer experience and using an AI recommendation engine? Well, maybe that could take their $20 billion of sales to $25 billion sales. And for the bargain price of $500,000 for you and 10 other people, you might be able to create, billions of dollars of additional money. So that's why an organization is going to pay the architects for the results we're taking, plus the executive skills. So if we do cloud architecture by basically starting with the executive team, and this is what a cloud architect needs to do, and then find the vision and goals for the business, where the business is now, where they want to go 6 months from now, where they're going to be 20 years from now. Because if we don't understand that, the architecture won't meet the business's needs. So keep that in the back of your mind. Think of that. So we start with the executive. Now we got to map out the business, understand key business processes, the organization's value streams, for example, the business architecture. Now, when we map this out, you're going to be dealing with executives and key stakeholders. And that means you need executive skills, which on average are $200,000-$300,000 skills anyway, to even have them. Now you're going to have to work with those key stakeholders and try to optimize key business processes and key components of the business architecture. Again, this is $250,000 to $500,000 a year strategy consulting work right there. Now what you're going to have to do is create a team of 15 to 50 people, look at the people's needs, and then analyze what they have. And you're going to have to you need a team to document all of what that is. And then ultimately, you're going to have to create a new strategy for that business, a new architecture. Then you're going to have to take that architecture, present it back to the C-suite, get buy-in from the C-suite. You're going to have to create a governance structure, a statement of work, a lot of documentation. So you're not going to have any time to be diving much deeper than a little bit into governance, regulation, and compliance. You'll be speaking with the organization's attorneys, because the people in the GRC team probably don't know enough about governance and compliance and regulations unless they're an attorney to go read these things. So I'd focus on cloud architecture if I wanted to be a cloud architect. If I wanted to do governance and laws and compliance, I'd get a law degree. I'd become an attorney, and then I'd bolt this on. And truth be told, when I did my CISSP many years ago, the first time in 2003, because you have to do your continuing education, etc. When I did that exam, there were a bunch of attorneys in that class. There were a bunch of business executives. And what they were doing is they were using their law degree as the governance, resource, and compliance, the expertise. And then they were getting the CISSP to know they knew cybersecurity, and that was their minimum. So kind of look at it that way. And I hope you understand why I said this. I'm just interested in your best goal. If you like GRC, that's fine. You can do it, but you'll have much more options as an architect. And if you try to combine the two, whatever happens if an architect tries to do engineering, they go to engineering. You can't focus on the big picture and create strategy and sell if you're busy focusing on any one of the components too much. That's why you need an architecture team of 15 to 50 people. And you may have an attorney on your team. I know I usually do. Good questions. What would I say to a cloud engineer who wants to listen, learn CCSK, and repeat other courses? I'd say it's great. I would say the CCSK is a really good intro. You could do the CCSP and give you a lot more. And that'll really give you what you need. Now, if you're an engineer, you may actually have to work with the technology other than design the technology. So then it may make sense to get like a CCNP security from a Cisco or a CCIE security if you really want to be good engineer in security, like a strong, great engineer, or a Palo Alto certification to configure those things. Whereas for the architect, it's more important to understand security, how to design it, and not have those vendor proprietary things to bias us, but still understand the vendors and what they can do and things of that. So I hope that makes sense. But yeah, that'd be a great plan for you. How does one go about creating a security policy if there's not one there for the organization? Well, in a perfect world, you don't have anything and you got to go in there. So you don't have all the baggage of something icky that needs to be really analyzed. So how do you do it? Well, whenever you do anything, the first thing you need to do is determine what the scope is that you're going to do and what objectives you're trying to achieve. Now, after you figure out what the scope is and you figure out what the goals are and the business needs and the business goals and any legal and regulatory requirements, now you're in a position to start assessing the organization's assets and the risk to those assets. So we've got to identify what are the assets? Is it data? Is it a system? Is it hardware? Is it a key formula? Whatever it is. And then we need to perform some kind of risk assessment and look at what is the risk and the threats to those systems that we're trying to protect. And then at this point, we're going to have to figure out who's going to do what. So we'll have to specify roles for like employees, managers, IT staff. We'll have to create, say, an accountability policy for who's accountable for what part of the policy, compliance, what have you. Then we'll have to design our security controls. So, things like firewalls, encryption, IAM, those types of things. And we'll also have to specify administrative type controls. For example, procedures, training, and auditing. Well, in there, we'll have to set incident response procedures. For example, how do we detect, report, and respond to security threats? We need to establish communication plans, how to talk to people should something happen. We need to come up with some form of compliance and monitoring. So define how the compliance will be enforced, compliance to what, whatever the business is in and its legal requirements, like HIPAA for healthcare, for example. Then once we do this and we create a plan, we're going to have to communicate the plan. We're going to have to train people on the plan. We may have to create marketing campaigns around the plan to get people's adoptions. We're going to have to get stakeholder buy-in in this. We may be creating education training campaigns, even big parties to get people excited. That's going to be often part of our architecture on how we're going to design this. And then we're going to have to review the policy and consistently update. So that's basically goes what's into it. But, that's a big content, and I tried to summarize it within the short time constraints that we have. Hope that helps. CCSK is really not known in Switzerland. In which countries are this certification pretty well known? Well, it's pretty well known because it comes from the Cloud Security Alliance. So it's pretty well known in a lot of parts of the world. Having said that, the biggest certification in security to do is the CISSP. And that's why we include that in our security architect training programs, because that's a big one. And I'll tell you, the CISSP probably has 10, 15%, maybe even 20% of the knowledge you need as a security architect. So kind of think about that in the back of your mind. The ISC squared one is much more common and much more well-known. And that's why I typically do recommend the CISSP for baseline security knowledge. To me, it was my intro to cloud security. Gave me an intro level about a wide variety of things, and it taught me what are the things I needed to learn more about in cybersecurity, which was really great. The CCSP is well known. The CISM is well known, and they're there. But this is what more well known than you'd think about because so many people actually did work on it. Good questions, Michael. I haven't been to Switzerland in a long time. Sounds like a fun trip. Chris, we can bring in the next one. That's it. So it's 4:50. We're supposed to stop at 5. So if I bring in the next topic, we're going to get out late around 5:45. So what I thought I would do is I guess I can end early, about 10 minutes early. And that's my plan unless anyone has any questions. So if you've got any questions about security architect careers or any tech career, I'll spend, 15, 20 minutes more asking those questions. And if not, guess what? We finished early on the first day. We've got a lot of fun time this week. We're talking security and cybersecurity. What if I told you globally there's a gap of over 4.5 million security roles right now? Then in the US, there's over 750,000, 750,000 open cybersecurity positions. So this is a really exciting world. The World Health, what do you call it? The Global Economic Forum, the people that meet in Davos are actually planning on security being some of the most so big that it's going to be in the impacts of tens of trillions of dollars, a lack of security people in the global economy. So lots of opportunity here. Will there be a future CISSP bootcamp? Hang Yink, what we do is we give away what other people would charge for completely free, because we've seen training that's any of the training that's less than $5,000 each. And we feel bad for the people that have actually taken it because I have to retrain almost all of their graduates. So what our competitors do, we give away for free. But when we get into a security architect program, when we get into something big like a CISSP, we include that in our premium programs, which we charge for, which are typically a few days' pay for the average graduate of our architect program, but we leave them there. But we have the CCSK, which is a good one, the CCSP, which is a really good one, and the CISM completely free on our YouTube channels, along with the CCNA, along with lots of training on BGP, along with an AWS Solutions Architect Associate and almost professional because we got much cheaper than the associate, the Azure Solutions Architect Expert, the Google Professional Cloud Architect will be a boot camp we're creating soon. So the CISSP we keep in our paid super special programs to give our students the competitive advantage over what else is out there. Good question. Could I give you a roadmap of which certifications to target for a lucrative cloud security careers, especially in the healthcare section? So what I'm going to tell you right now is all you get as certifications, you're never going to get a job ever. I'm going to make this clear. You will never get a job with just certifications unless it's the Cisco certified internet expert. So why is that? Certifications give you some information, but they're focused on an exam. And there's things that are different in reality. For the AWS Solutions Architect Professional, it is a very good entry level cloud admin, not cloud architect exam, where it teaches you what AWS marketing people called their services. And so, for example, a virtual machine, their marketing people named EC2, object storage, their marketing people called it S3, and any other silly marketing terms the cloud provider made up. Now, they also teach how to configure these things, which again, architects don't configure. So that's what you get in a certification. But what does that AWS certification not teach? And I'm going to tell you right clearly. So you want to be a cloud architect, you have to design a solution. They won't teach you how to do it. Present a solution. They won't teach you. Build a business case. They won't teach you. Give presentations every day, not in a certification. Manage stakeholders, not in a certification. Manage vendors, not in a certification. Build a business case, not in a certification. Now, we teach them in all of our architect programs, but they're not going to be taught there. Now, the next thing you're not going to typically get in a certification is how to design it. You finish the CISSP and it tells you a little bit about each of the thousands of components of security, but it doesn't teach you how to put the pieces together, because in order to put the pieces together, you have to know what problems you're trying to solve, what your customer challenges are, and how to even approach the questions. So that's why we actually created architecture training. That's why David Lithicum, for example, works with us for cloud security, or I'm sorry, for cloud architecture training and AI architecture. And it's why I had to create this. So if you tell me what your goal career is, then I can tell you the list of skills that you need and certifications that are going to get you there. But the certifications are like wrapping paper on a beautiful gift. You are the gift. It's your skills that are your gift. It's the judgment that is the gift. It's how you interact with others and how you bring out the best in others and how you contribute to being a team. That and what your knowledge is and what your ability to solve problems is. And you're not going to learn that. So if you tell me which career, I'll tell you the skills you need. For example, if you told me you were going to be a cloud architect, I could easily tell you that the skills you're going to need are sales skills, executive presence, CXO relevancy, business acumen, leadership, high levels of emotional intelligence, presentation skills, executive communication skills, and a lot of business knowledge. On top of that, you need to know networking and data center things. For example, from the network side, you might need to know BGP, IP addressing, subnetting, supernetting, for example, which wide area networking technology to select, like a VPN, for example, or a SASE WAN or a private line. How would you design various security components? So all that stuff, none of it's ever going to be taught in a certification. But the certifications give you a lot of value. The certifications will get you an interview in many cases, which is great. So then you have to learn the skills that are needed for the job. And depending upon the job, it'll be different. So a cloud architect gives a presentation, designs a sales thing, manages stakeholders, and does not touch the technology. By comparison, a cloud engineer is a hands-on role. The cloud engineer will be working with infrastructure as code like Terraform. The cloud engineer will be scripting things and automating. So a cloud engineer would need to know Python, where a cloud architect wouldn't. A cloud engineer would need to know Bash scripting and Windows PowerShell scripting, which a cloud architect would not need to know. A cloud architect would not need to know how to work with Linux, but a cloud engineer would, and maintain Linux and install applications and patch a kernel. So the skills for the jobs are so different. I need to know which job you want, and then we can figure out what skills you have, and then we can figure out which ones you need to learn. Same way as creating an architecture, but don't expect to get a good career by just doing certifications. And if that's your only approach, then I recommend a CCDE or a CCIE, and be willing to put in the $20,000 to $30,000 of training to get that done, to be willing to put in the 1,000 to 3,000 hours of training to get it done, the long nights and the studying, because they're the only things, those high level certifications, that after 3 or 4 million people have attempted it, only 60,000 people have passed. They're the certifications that guarantee you a job, because they're so hard that in order to pass the exam, you must be competent. But I got to tell you, certifications can boost your brand. They can get you greater interviews, and they can help you very much. And then the skills that you learn determine how well you do. And once you reach a very high level in your career, like an executive level, my manager, for example, at Cisco, who was a VP, said, Mike, take the certifications off of your business cards. And I was horrified. I said, the CCIE cost me close to $40,000. The CISSP was stuff. Why do I have to take these off of my resume? And my manager says, well, Mike, you're an executive architect. You're dealing with CEOs, CIOs, CTOs, CISOs every single day. Do you want them to see you as an executive or a techie? Executives get paid this, techies get paid this, and it's a whole lot less. Which job do you want, Mike? So I love certifications. They can be a great way to learn, and then they'll get you an interview. And it's like, for example, what we teach people in our main training programs are the things that get them hired, not just the interview. But certifications are important. Do get a few of them, and you'll do great. But I give you some kind of badge at the end of the boot camp. What point is it for me to give you a badge at the end of the boot camp? Nobody cares about it. For example, when do I care about a certificate of completion? Let's say you went to Duke University and spent 10 months there in an executive leadership program. Someone would absolutely care about that. Now, why would they do that? They can guarantee you're in the room, which I can't guarantee. I can't guarantee that you've even been here, that you didn't see more than 5 minutes. No, what I can tell you, Pablo, is by the end of this, You'll have the skill to go sit for the exam and pass that certification, and that'll be meaningful to somebody. And it'll be about 1,000 times more meaningful than just a certificate of completion. And what I've done here is not only give you the certification and the e-guide to easily pass the exam, assuming, but I would use a practice exam and practice test, but I've also given you a lot more knowledge to build your career. So that's what I want you to think of. When somebody comes with me with a resume that they've got 100 certificates of completion, I just throw the resume out and don't interview them. Now, if they've got a resume which clearly defines what they can do and what skills they have, wow, now I'm interested. So, for example, I see Bob. Bob is in the chat box. Bob was someone with a great background as an engineer, top-notch engineer. We trained him, and about a year later, he's worked as a security architect. Now, Bob would create content, and every time Bob would create content, he can verify this, he's in the chat box if he's still listening, you'd literally see 5, 10. He'd be getting calls each day to interview because he was showing such a degree of expertise when he created content. I want you to show your expertise. That's the world. People get hired for expertise, but they get brought in on the interview for a certification. So, hope that helps. And they are very beneficial in your career. Do I offer internships with the course or something similar? Our internship course is 1,000 hours. My students right now, last week, we're in the process of designing, doing a cloud repatriation because a lot of people, for example, are leaving the public cloud due to cost and going back to the data center. But they love all the cloud features and functionalities. So they're moving to Nutanix clouds and OpenStack clouds, for example. And all my students had to get requirements from a business case and me. They worked together, created the architecture. They presented the architecture back. They responded to the architecture's RFP. They created their architecture documents. They gave their presentation, and I gave them feedback. And now next week, what we'll do is we'll actually show them all the weaknesses in the architectures and what would be the best. So we're doing there. My students are doing real architect work every single day. So yeah, we have an internship to every single person that's inside of our course. And sometimes we go even involved in much deeper internships for certain people that would desire. So, but everybody that's with us is going to get a title once they're actually working in the program and have done a certain percentage of the work. They'll get work to do, and it'll be real architect work, exactly what you would do in the real world. Is it necessary to get 2 different degrees if you have 2 different degrees in cybersecurity? Well, most of us know that people with master's degrees and PhDs in cybersecurity really don't know any security. So I've worked with a lot of people with doctorates and other master's degrees in cybersecurity, and they had a good academic thought, but they really didn't know what they didn't even know yet. So we ultimately had to teach them. So if you have a bachelor's degree in cybersecurity, great. It's going to help you get an interview. But I'd still get the big security certifications, and I'd still get training to learn all the skills I need because you're probably not going to have those skills yet. So I would say to do that. Now, the best degree that I like in an architect, for example, is an MBA. So kind of keep that in the back of your mind. The architect's role is mostly business. Now, I've gotten people like Daniel Boso who dropped out of high school and didn't even have a GED, a job as an architect at JP Morgan Chase. And I've gotten plenty of people without degrees jobs as an architect. But it's all about your skills and your capabilities. And you're going to need more than just a degree. You really, really are. For example, the people get out of school with computer science degrees, then you put them through some training, then you get them skilled, and then they get hired. And they have the academic degree, which also looks good on paper. And then they have the real skills, and now they really do well. So you need both. It's always a combination of both. So when it comes to anything, and maybe I finish on this, it's not just your degree. It's not just your skills. It's not just what you've done in the past. It's a combination of everything. So I've spoken to thousands of employers and hiring managers over the year. And when you ask them what makes their hiring decisions, I can tell you right now, it comes down to a lot of things. First, it comes down to your competency, or what they feel is your ability to do the job and do it well. Now, that's going to be based on questions we ask you, especially for architecture roles. So we're going to have to do that. So that's going to be part of it, is the competency. Now, the other factors that are going to go into it are, can we trust you? Do you communicate well? What's your attitude like? Are you energetic, enthusiastic, passionate about the work, or do you look and feel tired or lazy? Don't hire, for example. Um, are you willing to go above and beyond when there's a major challenge in the end? Are you willing to stay till 3 o'clock in the morning, 4 o'clock in the morning, or work all night if that's what it takes? Not that it'll happen every day, but if and when an emergency happens for the company, will you do it, or will you say, I've got something else to do? Can you work in a team? Can you lead the team? Can you raise the energy on the team? All of that matters. And you know what also matters? How much the employer liked you. This is very critical. The first person I ever hired, his name was Shanur. I interviewed Shanur. I was at MCI WorldCom. He was a great, great person. I asked him a networking question. He didn't know. I asked him some network security questions. He didn't know. But he was honest about what he didn't know. And then I said, Shanur, clearly you don't know networking, but what do you know? And he told me Windows NT. And I asked him Windows NT 4.0 questions. I was lucky enough that I was in MCSE, which I never used. And I knew all these Windows things. And I asked him questions, and the answers he gave me were so good. So I remember going to my manager and saying, I need to hire this Shanur guy. And my manager, Dave, says, Mike, is he solid? Is he a good networking person? I said, honestly, not at all. I said, but his character is extraordinary. His energy, enthusiasm, and passion are some of the best I've ever seen. Has attitude. I gotta have this guy on my team. Guess what? I hired Shanur. He stayed at the company for approximately 17 years. He moved into good leadership roles. And then Shanur, who was always a caring person, always worried about those that were less fortunate, started some company to create extremely low-cost computers, to bring computers to the developing world that were like $100 or $200. And he's gotten computers into the hands of people that never had one before. And I'm so proud of Shanur. And if I didn't bring him in and give him the chance, who knows what he would have done? So there's a lot of factors that go into what we hired. It's not a singular focus. And when it comes to winning the interview, it's about focusing on all these things. So I'm going to give you a secret that most people don't know. And this is really important. For most architect jobs, for example, there's $100,000 to $200,000 pay range. For example, a principal architect at Google, the average pay is $508,000 a year, but the range is $394,000 to $677,000. Whoa! Almost $300,000 difference for the position. Why? Well, if we like you more, we're going to pay you more. If we think you can close more deals sales-wise because you've got more executive presence and more business acumen, then you might be worth an extra couple $100,000 a year, because you might bring in an additional $100 million a year in revenue. So all that stuff goes into determining total compensation. And that's what it talks about. So when you don't have a perfect background, like I know when we train everybody assuming they didn't have a perfect background, and we focus on how they sell themselves and how they interview and how they create their resume too, how they present themselves and how they have and we train them in the business, the leadership, the executive, and the attitude. And that way, when they go on an interview, they're not just a person without experience. They're the everything great, and then they still have competency. So when you plan your career, wherever you train, I encourage you to get everything. Focus on you, the whole thing. And I also want you to learn your competitive advantage. What is it about you that you're better than everyone else? My ability was a couple of things when I started tech. One was my ability to get accurate information from someone, which I learned in the practice of internal medicine. And two was my ability to always stay calm, which I learned as a paramedic firefighter and when I worked in the ER in healthcare. And then my other ability was to be able to clearly communicate and explain technical things. Where do you think I learned that? Healthcare. How do you describe someone the need for a cardiac cath and what the procedure is going to be like? This is complicated stuff, but medical people are trained in these things. So that substantially enhanced my value because I knew that was my competitive advantage, and I worked on that strength, explaining complicated things like cybersecurity as simply as possible. But maybe your thing is you speak well, that's your gift. Or maybe you learn faster than anybody else. Whatever it is, I promise you, I guarantee every one of you here has some special magical gift that could be your competitive advantage. If you're with us, we'll teach you how to find it and how to use it. If you're not with us, please go find it. Ask your friends, ask around what they think you're so good at, and then figure out a way to use that. All right. So I don't see any other questions. We're 8 minutes off. I've had so much fun with all of you today in this free CCSK Certificate of Cloud Security Knowledge Training Program to prepare you for V5 of the CCSK exam, to prepare you for that CCSK certification. Maybe invite a friend to see this. If you think this would help them, please do so. This is free training. It costs a lot to put together, and we want to help as many people as possible. If you haven't given a like, please do so. Give a like, subscribe to our channel, and hit the bell. It will inform YouTube to give the video and share others. Plus, we want to see you come back for videos on preparing for interviews and other things. So it's been an honor to meet all of you. Make sure you download that completely free cheat sheets or sign up for them. Make sure you, if you want to be an architect, join us in the architect webinar on Thursday. It's for security architects, but I'll answer any other architect questions: cloud architect, AI architect, enterprise architect. I don't care. I've had all these roles for over 25 years. I love them, and I love helping people. So can't wait to see you. Hopefully I see you on Zoom and we get to meet face to face. Take care, everyone, and have a wonderful night.